Hello everyone and welcome. This is Michael Gibbs. We're here for the third day in our AWS Certified Solution Architect Professional Bootcamp. Can you all hear me? If you guys can let me know if you can hear me and maybe tell me your name in the chat window below. We're super excited to have you here. Hi Theo, hi Smita, Derek, so happy you're here. Cloud Def, welcome all. Looks like we've got some more people. K1, awesome to see you. Akash, welcome. Balwinder, wonderful. Cloud Def, Super Brigadier, wonderful. K1, Rick, so happy you're all here. When we run these things, we typically find that, in the first couple of days, there's lots of energy and enthusiasm, and the people that really stick around are the people that are really going to get to their goals. So we're here to help you get to your goals, and we are really excited to do it. If you have not been here for the first few days, I'll let you know that my name is Mike Gibbs, and I'm the CEO of Go Cloud Architects, and that I've been working in tech for well over 25 years. I started out as a network engineer, then a network architect, then security, then a cloud architect. I've done these roles for 25 years, and I've spent the last 2 decades literally helping people find their first tech jobs or get promoted in tech, and it's something that I am so passionate about and absolutely love doing. I love helping people build their tech careers. So on the first day, we talked about some networking, and yesterday we talked about computing and some databases, and today we're going to come back, and we're going to talk about how to optimize your database to maximize performance for maximum scalability. So that's what we're going to talk about today is database optimizations. That's where we're going to begin, and then we're going to get into a lot more depth over the next 3 hours. I'm excited to have you all here. Please let us know how we're doing. If there's any questions that you have, Chris from my team is going to be watching these things, and Chris is going to be basically summarizing questions. The format for today will be as follows: 20 minutes of lecture. And after that 20 minutes of lecture, we're going to have about 10 minutes of questions. We're going to do this through the entire time. Lile, I'm so thankful for your kind words here. We're excited to have everyone here. So today we're going to begin by talking about database optimizations. And we talked yesterday about relational databases. As a reminder, relational databases are used to show the relationships between variables. Organizations use relational databases so they can find out if they affect one variable, how it will affect another variable in their business. And that's why organizations use relational databases. Now, since architects are designers, I'm going to remind you that organizations use no SQL databases, meaning not only structured query language, because they need scalability, they need customization, they need flexibility in their schema. So we talked about how to choose the right thing. So if you're an architect or an engineer, you're going to need to know which database to choose. And then we talked about data warehousing databases being designed to basically store large amounts of information so you can make better business decisions. That's why we use data warehousing, and we talked about the creation of data lakes. And we talked about the creation of data lakes, which is where you integrate some object storage, multiple kinds of databases by using some ETL tools so you can glean benefits of all of them. Now, how do you scale a database? How do you create high availability? How do you improve performance? Well, that's the fun we're going to begin today's conversation with. So let's talk about when you're backing up, when you're encrypting. Let's talk about things we should do with the AWS database environment. When it comes to databases, we're going to talk about how to back them up. We're going to talk about how to their scalability. We're going to talk about encrypt them. Let's first talk about backing up the database. And then we're going to talk about scalability. And when we talk about scalability, we're going to be discussing read replicas, caching, queuing. And then we'll get into the high availability discussions where we're going to talk about multi-AZ and other components. So these are the things that we're going to talk about, but we're going to begin with database backups because that's honestly one of the more simple things to cover. And if you're going to have an environment where you're going to have a lot of data, and the data is critical to your business, you can't lose that data, so you're going to have to back it up. Now, someone said I froze, so let's make sure you guys can all see me because there's a 30-second delay. So I'm going to monitor the thing for a little bit. But if you're backing up your data, it needs to be done in a way. So the good news, when you're using databases that are part of the cloud solution, this is the most simple and elegant process in the entire world. Databases on AWS, when you use their services, at least if you set them up the way they do it, what you can actually find is the entire database will be backed up. Now, there's two ways you can do backups in the environment. There's those of us that have done traditional backups. You use tapes and things and you back it up, or you copy your files over. That's one type of backup. But the automated backups that exist with the databases in AWS are fantastic. Why are they fantastic? Your databases and information is going to be stored on an EBS volume, or basically just your traditional block storage, which uses your primary storage function for your databases or most things on the cloud. And that whole volume is going to be backed up into an image. It's going to create an AMI or an image. This means that the backup that you have will be 100% configuration. So if anything happens to your server, you go back to your last backup, you launch a new compute instance, and poof, you're literally up and running with your database with an identical copy, and you can do it in seconds or a minute at least. It's that fast. It's different than if you had to basically rebuild the entire server, install the applications, and restore your tape. So backups on this are incredible. They're elegant, they're simple, they work. You know me, I'll tell you when the cloud is better. I'll tell you when the cloud is worse, because as an architect, you need to know. This is awesome. The automated database backups. Now, the backup is the entire database, and the backups, you can retain them from 1 day to 35 days. Backups, at least these automated backups, will happen during a predefined window every day. Now, one thing to know about when these database backups occur is it takes a lot of CPU memory and disk performance. So these backups can, realistically speaking, make your database unavailable for a short period of time. So understand that your performance is going to be degraded or unavailable and when the thing is being backed up. Now, one thing I wanted to remind you that when you're using these database backups, if we're going to relaunch them later, and we're going to talk about that, they're going to come up as a new compute instance, which means a new IP address and a new DNS name. Everything else will be identical, but that, so just please understand that. So the database snapshots are going to be performed. You can do a manual database snapshot as well, which is going to be a point-in-time copy. And when you make your manual ones, they're there and stored until you need them. So think of it this way, is when you actually look at something like this, what you'll see is you're going to have your Amazon database, and it's going to be backed up into a snapshot. Now this snapshot image, this image of itself is literally going to be an identical copy. It's a pure image of your system. So just remember that. Now, if we backed it up this way, how do you restore it? Very simply, when you restore your database, you basically launch a new instance coming out of your machine instance, and now you've got a new database. But because it's a new instance, it has a new IP address, and because it has a new IP address, you're going to have a new DNS name. So now we talked about the need to basically back up your data and how to do it in a very simple and elegant environment. But let's talk about your data storage. Let's say, for example, your data is stored on this block volume and someone were to steal your hard drive. Well, that'd be pretty horrible, because then they could access all your data. So what should you do? You should make sure you're using encryption on all of your EBS volumes. Just like you would for a standard compute, you're going to do it for your database. So this basically means encrypting the drive, the EBS volume where the server is. And the way you're going to do this is you're going to enable the key management service. And the key management service is a managed service to help control your master keys. So while we're talking about these kinds of things, there's lots of ways you can do encryption. You can encrypt the volume. You can do transparent data encryption, which is basically an on-the-fly encryption when you need it. And this is typically done by Oracle and Microsoft SQL databases. They typically use this. Or you could do transparent data encryption with Cloud HSM. Basically, it's a form of encryption that encrypts and decrypts your data on the fly, on demand. And that way, when you send your data to storage, it's encrypted, and when you pull it, it gets decrypted, and that way you've got a security for your data when you need it, and then you can read your data. So that's typically the way these things work. So the other way you can do encryption is basically called encryption in transit. So what encryption in transit means, you encrypt the data on the way to its destination. So you can use the TLS protocol or with SSL certificates typically to do these kind of things. So there's a certificate that's going to help with authentication of the endpoints and encryption of your data. That's the way you could encrypt your databases for encryption in transit, which is different than encryption at rest. Encryption at rest is when you encrypt the volume where your data is stored, versus encryption in transit is actually related to while your data is being there. In networking for encryption in transit, we use IPsec. For web pages for encryption in transit, we use SSL. And that's what we're using here for the databases. So let's talk about how do you make these databases scale. Well, here's the thing. Databases are different than traditional applications. Here's how you normally scale an application. If 9 servers is enough, you add a 10, an 11, a 12. You use a load balancer. Works great. But you can't do that with databases. They function differently. So we're going to talk about how do you scale the database. So let's talk about scaling the database. Since the database is mission critical and the database matters so much, how are we going to scale it? Well, we're going to talk about scaling up and scaling out, and we're going to talk about the process to do all these things. So the simplest and easiest thing to do is to do what's called scaling up. What is scaling up? Scaling up is quite simply using a bigger server. More CPU, more DRAM, more IOPS in the drive. That's scaling up. That you're going to do. Here's the problem. There's going to be a point in time where these 128 core servers with 4 terabytes of RAM, they're not big enough. So then you're going to have to do what's called scaling out. And that means adding additional computing instances, additional servers. So you're going to have to scale up and scale out. And because at some point you just can't scale up anymore. There's just not enough servers that meet those kind of requirements. So there's different ways that you can scale these things out. If you're dealing with a NoSQL database like DynamoDB, Apache Cassandra, Google Cloud Bigtable, this stuff is easy. Why is it easy? You just partition the database. And when you partition the database, it basically chops it up into partitions. And of course, there's intelligence to route data in between partitions, which breaks your data into manageable pieces, which basically means you can just add capacity up to like 2 billion cells. These things really scale. And all you have to do is partition the database. It's like you have a new database. And having multiple small databases with basically some routing between them, now you've got a very scalable solution. That's why things that are really needing to scale almost exclusively use NoSQL databases like DynamoDB, Google Cloud Bigtable, or Apache Cassandra. Widely used everywhere because they scale and they have flexible schema. But it's a different process for relational databases. Most, not all of the relational databases get scaled out in a very unique manner. So if you want to improve your database performance, after you've moved to the biggest server you can, now what? Now you got to scale out. But you can't just scale out and add compute instances with a load balancer like you could. Here's where you got to get creative, and here's what you do. So you add additional compute instances, and they're in the form of read replicas. We're going to talk about caching, and we're going to talk about reducing write load, because we have to reduce read load and write load, and we're going to talk about the difference. So as it comes out, the way you learn, every time you read or every time you write from a database, you're using CPU cycles and you're using memory and drive speed. Every time you read and every time you write, it's taking it. So if you could pull the read activity off the database and then it only does write activity, the database or the master database is effectively going to do 50% of the work. So reduce read load, reduce write load, now your things are going to scale. So the first thing we're going to talk about is reducing read load. We're going to do read load by creating something called a read replica. What is a read replica? Outside of MariaDB, a read replica is a read-only exact copy of the database. And it provides additional servers to reduce the load, specifically the read load on the master database. So what's this going to look like? What you're going to do, and I'll show you graphically what this is going to look like in a second. In this environment, what you're doing is as follows. You have in this diagram, what I drew is a traditional 3-tier app. You've got a web server, an app server, and then a database. And you can see M is the master database, and the R's are read replicas. So what happens is we added 2 read replicas. Any read activity, we're going to point to the read replicas. So we're going to send all the dashboards, all the stuff that people are going to pull, we're going to point them and query it to the read replicas. All queries will be directed to the read replicas, and basically now we pulled all the read load off the master database, so now all the master database has to do is write. So we've knocked off basically potentially 50 or more % of that traffic off of the database by adding read replicas and spreading the load. So that's part of it. So we can add up to 4 read replicas as a rule, which means we can really dramatically reduce the read load on the servers by adding read replicas. What else? 4 read replicas may not be enough. We might need 50, but we can't go above 4. I mean, we could do some kind of nested read replicas where you have 4 read replicas and then each replica has like 4 more. So we can do that, but that adds additional latency, and there are times where we still need to do that. But let's talk about what else we could do. What if we wanted to reduce the load? What if, for example, we wanted to reduce the load on the read replicas? Guess what? We can do that too. We can implement a caching system. So for those of you that are not familiar with caching, here's the way caching works. Caches store access to frequently accessed information. So for example, if I stick a cache in front of the read replicas, the way this will work is if I run a query and my query has not been seen before, my query will go to the cache, it'll go to one of the read replicas will respond, and the cache will store the information. Now the next person that goes and does the exact query that I did will go to the same database cache. The cache will say, here's your answer. So it's going to reduce the load on the read replicas by only sending some of the requests to the read replicas. By doing that, we reduce read load on the read replicas additionally. So what are we doing? We're taking the database, we're taking the read load off of the database with read replicas, and then we're adding a cache to further reduce the load. So caching basically takes a request and stores it so future requests don't have to be to the read replicas. By doing this, we've further reduced the load on the read replicas. Now, granted, the cache is not going to store this information forever. We're going to have to set what's called the time to live. What that really means is the information that's going to be stored in the cache is temporary. Why don't we keep it there forever? I'm going to tell you why. Whatever's stored in the cache is going to be old data. Until it times out, users are going to be getting the same information. So we're going to basically be using a cache with a certain timeout and basically going to use that to reduce the load to the read replicas. Now, when you're dealing with AWS, you're dealing with Elasticache. Now, in reality, in most data centers, you're still going to deal with Redis or Memcached as a cache. These are basically your same services that are offered in the cloud, and thankfully they're compatible with whatever you're doing in the data center. So either way, you're going to be good. So when you're dealing with AWS, you have 2 caching options you can choose from. Elasticache for Redis or Elasticache for Memcached, pretty much the same services you'd be using in the data center. Now, Elasticache for Redis is really cool. Super rich feature set, compatible with traditional Redis. So if you're running Redis already, you can migrate your workloads to Elasticache, no big deal. Think Redis, think high performance, lots of features, lots of tunability. Redis is your go-to cache when you've got a lot of work to do. Now let's look at Memcached. So with AWS, you have Elasticache for Memcached. Simple caching, designed for simplicity. But it's also compatible with Memcached, so any tools your organization may have are going to work perfect. These are pre-built caches, that's all they are, but it's a way to further reduce this. So take your database, add read replicas to reduce the read load, add caches to reduce the load on the read replicas. That's what we're doing. The caching will therefore lower the CPU, memory, and disk I/O requirements on the read replicas of the database. It's going to improve performance, it's going to reduce latency, and it's going to improve scalability. Caching is your friend. All of this that we've talked about so far is designed to reduce read load. Remember, when you're dealing with databases, you've got read, meaning pulling information, and you've got write. So we're going to have to talk about that soon. In write, out read. So we have to do this. So you can see what this caching actually looks like in an environment. Here we have a high availability database design. We've got the database across 2 availability zones for traditional 3-tier web service. We've got web tiers, we've got an app tier, we've got a database tier. Note the cache that sits in between the databases. The cache will point to the master server, and if anything happens, it will fail over to the backup standard, and the cache is going to help with all these requests. Caching reduces read load. So before we get to write, remember servers, database master server, read replicas reduce read load, caching reduces read load even further on the read replicas, makes the solution more elegant. Now, that's what we do for read, but what do we do for write? Here's what we do for write. We implement queuing. So what is queuing? Queuing is a means to take your data from point A and on the way to point B, have an intermediate stop. So send your data to the intermediate stop and then send it to the database. By using queuing, we can do some amazing things to improve the performance of our database. Queuing will dramatically reduce write load by smoothing it out. So we reduced read load with read replicas and caching, and we're going to reduce write load with queuing. And I'm going to show you how this is going to work and why it works by a couple of things. People use queuing to decouple their application architectures. And you may see that on an exam. Queuing is used to decouple your application architectures. So let me show you what this is going to look like in the queue, and then we're going to talk about how it all works. So the way your queuing is going to work is, let's say you've got your app servers. It's going to put your message in the queue. Let's say an order came in. So somebody goes to the website. After they hit the website, they hit the app server, and they get an order. The app server sends the order to the database. Well, it would, but in this case, it's going to send it to the queue. The message is going to sit in the queue until the database is ready to receive the information. And when the database is ready to receive the information, you know what's going to happen? It's going to be coming out of the queue. And when the receiver receives it, it'll notify the queue to drain it from the queue. So it's just an intermediate hop along the way. And I'm going to show you in a minute what it looks like graphically. But basically speaking, queuing is what people do to decouple application architectures, and by making it more modular, it makes it much more scalable, and it can dramatically improve the performance. Now, you could build your own queuing system like most people do, but when you're on the cloud, it's pretty easy. Amazon has a very simple pre-built queuing system. They call it SQS, or Simple Queue Service. This is one of those services that's nice and simple and elegant. Basically, it's a pre-built queue which you can drop your messages on the way to their ultimate destination, which is typically speaking a database. So that's where queuing comes into place. Now, when you're dealing with SQS, you have two options. You've got standard and FIFO. Standard is a simple queue. Messages come in, and as fast as the queue can be drained and stored. There's no guarantee of the order of the messages, but they come in and they come out, and they do really, really, really wonderful job along the way. So that's the way standard queues work. Now, if you needed, you could set up what's called a FIFO queue, or first in and first out. There's strengths and weaknesses to all of these designs. A FIFO queue means message 1 comes out of the queue before message 2 comes out of the queue before message 3 comes out of the queue. Could be good. But understand, if message 2 is really big, it might stop messages 2 to 3 through 27 from coming out, so that when you're using a FIFO queue, it could really slow things down. How do you determine the kind of queue you need? Whether just send them in and out as fast as they need, or whether to go FIFO? Quite simply, it's based upon your applications. If your applications can tolerate out-of-order messages and work around them because it's built into the application, always use the simple queue. It's higher performance, it works better. If your applications cannot tolerate out-of-order messages and message 1 needs to come before message 2 versus message 3, you're going to use a FIFO queue. That's simple, that's it. It's based upon where your messages are working. So let's look at this visually so you can see how queuing actually works. Now let's say you've got your 3-tier app. Somebody accesses the web server, then they hit the app server, then they stop at the SQS, and then they stop at DynamoDB or it doesn't matter, Aurora, MySQL, whatever the case is, it's a stop. Now look at what the CPU typically looks like on a database if you don't use queuing. There's some of the percent of the time it's going to be 20, some of the percent of the time it's going to be 80, then it's going to go to 40, then it's going to hit 100%, then it's going to be 0. When your CPU or your network performance and your memory is almost utilized, all up, bad things happen. Bad things happen. What do I mean by bad things happen? Messages get dropped, orders get dropped, things are lost. If you're a business and you have peak things and you lose 30% of your orders, that could be catastrophic to your profitability. So this can't happen. What do organizations do? They build so much more capacity than they actually need to tolerate these weaknesses. That's what they do. Queuing, by definition, will smooth it out. So look at the CPU utilization, because this is typically what we see. We've got without queuing, without the SQS, it's all over the place. And with queuing, it smooths it out. So it drains the messages at a capacity that the server can do it. Queuing reduces write load. Read replicas reduce read load. Caching reduces the load on the read replicas. And SQS, or queuing, reduces write load on the database. This way you've reduced in and out, you've reduced the need for disk performance, you've reduced memory and CPU utilization. This is how you scale a database, because you can't do it like you could other things. It's not like you can just stick a load balancer to do these things. So that's why we're talking about it. That's how you improve the performance. So how does SQS help again? It reduces write contention and keeps messages from being lost. And SQS does one other thing that's really cool. Not so much with databases, but with other things. When you're using the simple queuing system, and you've got messages coming into your queue, and another message coming into your queue, and another message coming into your queue, if the queue's full, you can even facilitate auto-scaling outside of databases. So you can literally have more compute instances come up because the queue's looking full. So queuing is a wonderful way to decouple your messages, and it's a fantastic way to promote scalability in your architectural designs. So we've discussed this. Now, before we get into high availability, I want to talk about ETL tools and what we mean by that. So when you're dealing with databases, every database has their own strengths and weaknesses. Relational databases are beautiful because they show you the relationships between variables, which can help an organization make a better decision. Data warehouses can contain extraordinarily large amounts of information, and when you're dealing with a data warehouse, what's pretty cool about these kind of things is you've got lots of information, and it can be analyzed by business intelligence tools, again, so you can make better business decisions. You might be using some NoSQL databases because you need some flexibility in your schema. So in a global enterprise environment, you're going to have data warehouses, you're going to have NoSQL databases, relational databases, because they all offer strategic advantages. Better information, better decisions equal more sales, which equal more profitability. That's why organizations use tech. Organizations don't buy tech because it's cool, they buy it because it can improve their business strategy. That's why as an architect, it's not about configuring things. It's about soft skills, emotional intelligence, business acumen, presentation skills, writing skills. Why? You got to ask the organization their business goals. You got to find their strategy, you got to find their needs and what they're trying to do, and the regulatory environment, then you design a solution that meets these needs. That's why it's so important to do these things, and that's why architects and engineers are so vastly different in their skill set. We can talk about that when the time's appropriate. But understand that's why these organizations have so many databases. Since each database has their strengths, and they have their weaknesses, and they can help do things in a certain manner, it's really important to choose the right kind of database for your architecture. And the reality is, in a big global environment, they're going to need them all. Okay, so now we get into this complexity. Relational database, NoSQL database, data warehouse, lots of stuff, and stored in object storage, which could be part of a data lake. What do we do about it? We merge them. We integrate them so we can take the features and the functions and the benefits from all, so we can make really, really, really great business decisions. That's what we do. So how do we do this? Organizations, you purchase or create their own ETL tool. What is an ETL tool? A tool that extracts information, transforms it, and loads it into other databases. That's what we do. In order to gain the benefit of everything, we need to basically exchange information. It's kind of like having 5 friends on your cloud architect team. Having a security person, having an infrastructure person, having a network person, having an IAM person, and then having someone that's good at operations. That's part of your team. Why do you have all 5? Because you all have different skill sets and you make a better design. That's why organizations use multiple kinds of databases, and how do they integrate them? With an ETL tool. Now here's the good news. ETL tools are kind of complicated, but Amazon actually makes one. Again, this is one of those situations where the cloud makes it so much easier and the cloud is elegant. Like you've heard me, the cloud doesn't offer this, the cloud doesn't offer this, the cloud costs you this. This, great service, the ETL tools. So Amazon has its own branded ETL tool, and that's called Glue, and it's going to be a fully managed serverless tool, which is kind of great. And it's really what to use this ETL tool or Glue. You just point the tool to wherever your data is stored on AWS, and it's going to discover your data. It's going to basically create a catalog full of metadata, which is data about your data, so you can find it. After the data is going to be cataloged, it'll be searchable and queryable, and then the data can be queried and placed into a database or a warehouse. Very, very, very elegant solution, and I love that they provide it so you actually don't have to code it. So here's the way it's going to look and the way it ties things together. You're going to have some information stored in S3 because remember S3 is object storage, and object storage has, when it breaks data down into objects, each object has metadata, which is queryable and searchable. So anytime you're using object storage, it fits into your big data environment. Then you're going to basically using Amazon Glue, which is basically going to crawl all these things and pull information. It's going to pull information back and forth from a relational database, a data warehouse, like in this case we're using Redshift, and we're using Elastic MapReduce for another thing, and then we're going to be using QuickSight to visualize the tools. So these are the kinds of tools that we talk about. Now at this point, what I'm going to do, we've actually now spoken for probably more than 20 minutes, and I'd like to make sure we don't answer any questions. The people from my team have told me that I should tell you what we do as an organization, and then I'm going to answer questions. As an organization, we provide cloud architect training. We teach people how to become architects, letting everyone know here that certification is about 10% of the process. The remaining process is soft skills, emotional intelligence, presentation skills, design skills, understanding how all the pieces work together. We have a 250-hour cloud architect training program called our Career Development Program, which basically teaches people how to become cloud architects and how to find their first jobs. I'm going to put a link to the program if you're curious, as well as a link to a 20% coupon if you're curious. And then I'm going to go start answering questions. But I have to keep the rest of my team happy, so I'm trying to keep the rest of my team happy while I'm making this presentation. So I'm happy to answer any questions about our program, as well as the kind of training that we do. But in any case, now I'd like to see if anybody has any questions on any of the material we've covered so far. Does anybody have any questions? I couldn't see if there were any questions that were in the chat box so far. If anybody has any questions, if you could repeat them to me. Okay, I see one. Hamza, you want to be a cloud engineer, and you've done the associate's courses and doing job. From where should you start? Does this mean that you're actually working as a cloud engineer, Hazma? Because you said you've done courses and also doing job. I don't know what you mean by doing job. Are you working as a cloud engineer? If you could let me know, I'll happily answer that. The next question from Izar is, I passed AZ 104. What you think I should go to a cloud solution architecture or AWS security? Ivar, if you tell me your goals, I can make recommendations. Certifications are never the goal. Employment is the goal, and your ultimate career is your goal. If you tell me your goal career, I can absolutely, and you, as well as your background, I can recommend certifications. Here's the thing with certifications. They are really good at helping you get an interview, but they will not get you hired, but they help you get an interview. What do we use certifications for? Quite simply, we look for the gaps on your resume compared to what hiring managers desire. And we use certifications that are going to fill in the gaps on your resume and only that. For example, if you've been in networking for 20 years, I'm not going to have you get a network certification because you've got lots of networking certification, not experience. Likewise, if you've worked in the data center, that's really great. We're going to use that in your portfolio, and we don't need any data center things. So it's all about finding out where you're starting from and your ultimate destination, and then that's how we build you the map. So if you give me the information now or one of the next breaks, I will happily answer those questions, but I need to know where you're coming from. Portia, thanks Mike. This is just the type of project you're working on. How would you trigger Glue to extract S3? So basically what you do is if you're using a Glue crawler, it's pretty simple. You just point it to where your data is on S3 and you help tell it the destinations, and it's pretty much automatic from there. So that is basically something that makes life pretty easy. I see Andrew asked a question. Did you say it's possible to scale based upon SQSQ? Yes. Not for databases. And you'll probably see this in one of your exams, in that Certified Solution Architect Professional exam. it's pretty common to look at the message depth in an SQSQ and actually use it to scale to provide auto scaling. What a great way to actually scale based on actual needs. Ramya, is it possible that the data in the cache can become stale? Absolutely. And that's why you set a TTL that's appropriate for your database. Let me ask Arif said, can you talk a little bit more about TLS? TLS, or Transparent Layer Security, is a type of security that's actually used when you're actually encrypting things that are in transit. For example, normally speaking, at the network layer, we would use IPsec. And so typically, but you could also use TLS, which is basically the way websites actually typically encrypt. Basically, you're using a certificate and you're doing some encryption. I can talk about that more if you desire. I've been asked by a lot of people to create a course on networking and security. Do you guys want me to create an AWS Advanced Networking? If so, tell me that in the comment section. Say AWS Advanced Networking. And if you'd like me to create a course that teaches networking, that's real networking, that really matters to help you guys, let me know. Type in networking or AWS Advanced Networking based upon what you want. And if you want both, type cloud networking, type networking and both in the comment section, and I will build some training and I will do it free over YouTube Live for you and within the next 30 days. Let me know. Raphael, when you talk about all of these professionals implementing what you have architected, is it happy if you're working for a consulting company or a bigger company? Both. Architects design, engineers build. In a big company, you might have an architecture team literally of 100 people on it, all with a different background. And they all work together to design something. In a small company, you're going to have an architecture team and you're going to have a post-sales team. Still, there's going to be a lot of separation in roles, Raphael. You have to train for the job you actually want in order to get hired. So that's what we're talking about. And I'll do, if we get enough people saying networking, I will definitely do networking. I just want to make sure that there's enough of a demand. I was one of the original Cisco certified internet experts, and I've consulted to almost every one of the large internet service providers, and I love talking about networking. Before we get back to this, I saw Ivar had some questions which I couldn't answer because I was missing some of the information. So if you want to come back to that and provide some more information, we can answer that question on the next time we take a break, and I'm more than happy to. So the retention period for backups is anywhere between 1 day and 35 days based upon how long you set it. You can check the retention period on the AWS website. It's different every time. Always, always, always confirm with the vendor because they change things. And I think it's 7 days, but it's a long time since the last time I looked at it, and it's really not that important. What's important to know is see what it actually is on the website. But when you do your manual backups, they are kept forever until you do otherwise. So that's really what matters. Making sure you back it up and knowing what your retention periods are, because you have a lot of opportunity to talk about it. You guys want some networking and you keep telling me, I will produce some free networking training to try and help you all get to your goals. So now let's talk a little bit about high availability database design. Because when you're dealing with databases, what you're realistically speaking trying to do, you need to make sure they work. These are critical applications. So how do you design for high availability? Well, there's a rule in the military world, and there's a rule in availability. 1 is none, 2 is 1, and 3 is greater than 2. This means that one system does not make a solution. It will always fail. This concept of Murphy's Law, this evil guy Murphy that's sitting in the background that always causes problems, trust me, trust me, trust me, it will break. It will totally break. So in order to figure that out, it's going to break, so you must design for availability, which means you need more than a single system. Sorry about that. trying to make sure somebody from my team can make sure that we keep up with all of your questions, because I want to be able to answer all of them when they come in. So 1 is none, 2 is 1, and 3 is better than 2. This means you need a primary database and you need a backup database, because these are mission critical applications. Should you put your primary database and your backup database in the cloud next to each other? No. Could you do it in the data center, in the same data center? Sure. In a data center, you can set up a 5 nines available system in a building, if provided you do it the right way. It is impossible to do it in the cloud. In the cloud, the best you can get is 99.9% in one availability zone and 99.99% across 2 availability zones. So because you've got that low level of performance in a single availability zone when it comes to availability, in the cloud, because you're working with things that are nowhere near as good as you could get in the data center, you got to spread this stuff out as far as possible. So 2 availability zones at minimum, that's what it's going to take to basically give you acceptable level or 4 nines available databases in the cloud, which means an hour worth of downtime per year. Now, if an organization needs more than that, most do, they're going to have to be across availability zones and regions. So this is one of the situations where stuff in the cloud kind of gets ugly. Do you need to put your stuff in a couple of continents just to be able to have somewhat reasonable availability? Well, in the cloud you might. And because of this, you need to realistically see what's going on, where, how, why. So it's part of your design. You have to design into this. You have to think about it. This is why the architect is not an engineer. This is why the architect is in front of the customer. How important is your database? What does 1 minute of downtime cost you? What is your business strategy? What percentage of your orders go through the database? How are your customers affected if the database is down? These are only 2% of the questions that my architects are trained to learn how to do, because this is how you design things. Design is not configure. Design is understanding how it works, why you use it. So that's the difference between architecture training and engineering training. You must know these things, and that's how you kind of have to do these things. So realistically speaking, that's what you do it. So how do you do high availability database design? More than one, and you host them in multi-AZ environments. Remember, read replicas improve performance. Multi-AZ improves availability. It is not used. It is a backup database that's sitting somewhere else, and it is completely unused. What happens, you've got your primary database, and it asynchronously copies data to the backup database. And because of that, that's how it improves performance. By doing, or not how it improves availability, not performance, but it is active standby, so it's no performance. Read replicas, performance. Queuing, performance. SQS, performance. High availability, extra thing, sits there at rest doing nothing. It's waiting for you. So what does this look like, architecturally speaking? Here's the way it looks like. You've got your stuff. 3-tier web app database server. Web servers across 2 availability zones. App servers across 2 availability zones. Main database, backup. Main database in 1 availability zone, backup database in availability zone. Read replicas in 1, read replicas in another. Whatever you've got in your main database, you better have for your backup database, because if you don't have it, the performance isn't going to be good enough. So now let's talk about what will cause your databases to fail over. If you've got a primary and you've got a backup, primary and a backup, then your primary will fail over to the backup. But what causes this failover? If the main database fails, it fails over. And if the availability zone has an outage, it'll fail over. If you change the database service type, it'll fail over. If you tell it that it's under maintenance, like you're patching the operating system, it'll go. And if you trigger a manual failover, meaning reboot with failover, you want to patch your system, you want to reboot your system, then and only then will your systems fail over. So that's how you do these things. So we're going to go into the VPC. Looks like 2 or 3 more questions actually popped in, because the VPC is an entirely new topic and one of my favorite ones to talk about as a network guy. We're going to talk about it. So I think I saw 1 or 2 quick questions, which I'm going to answer. The last one is, for someone who's never been in tech but wants to become a solutions architect, what certifications do you recommend for starters? What kind of solutions architect do you want to be? That will determine, do you want to be a generic solutions architect, a security solutions architect, a network solutions architect? I need to know those kind of things, and then I need to know exactly what you'd like to do, and then I can guide you. As a rule, for generic people while I'm waiting for your things. To become a cloud architect or a solution architect, which is kind of like a junior cloud architect, at minimum certifications, you're going to need a certified solutions architect professional, nothing else below that. Do not take a cloud practitioner. It's a complete and total waste of your time. Complete and total waste of your time. It won't make you hireable for anything. Starting point for most people is the certified solution architect associate. For some people with a lot of background, I start my people with the certified solution architect professional. In addition to that, you're typically going to need some type of a certification from an industry and the specialty you choose. Networking, security, or the such. That will be 10 to 15% of what's necessary to get hired. The remaining part that's necessary to get hired before I move on to the next section is presentation skills, writing skills, business acumen, meaning know how to do ROI modeling to show an organization that if they spend $1 million on tech, it'll provide $200 million in terms of cost savings or additional business opportunities. You need to be able to do that. You need to know how to speak to the CEO, the CFO, the CIO, the CTO, the hiring manager, and with the management levels, the VPs, the directors, the engineers, and the architects. That's 50% of it. Then you need to learn system design. What is system design? System design is being able to take things and design an architecture. What is that architecture based on? The network and the data center. So that means you must learn server virtualization, containers, firewalls, load balancers, proxy servers, Linux, Apache, MySQL, the LAMP stack. Learn Active Directory from Microsoft, and then to learn how the cloud works. And then after that, realistically speaking, just to be able to be part of a solution architect, you should know how the cloud works. And how do you learn that? You build yourself your own cloud. These are the things that our students actually do in our program, and that's what's necessary to get hired. You can do it with us. You can do it on your own. I will point you to the link of our program, and you can literally look at everything that's in our program and figure out how to learn these things on your own. You could literally follow our model and do it on your own because, we're basically telling you what's necessary to get hired, or you can do it with us. We'd love to do it with you if you have an interest, but these are the things that are necessary to learn with us, on your own. It'll be a lot cheaper with us because we're running this as a cross between a charitable mission and a business, but these are the things that are necessary to do. These are my recommendations if you want to get a solution architect job. I generally train people to become cloud architects instead of solution architects, because a cloud architect can work as a solution architect, but a solution architect can't work as a cloud architect. And cloud architects typically get paid much better than solution architects. Cool Dude 5699, do you need to learn Linux commands? You need to know how Linux works. Absolutely. As an architect, you're a designer, not a configurer. So no, you don't need to be an expert on doing Linux commands, but you do need to know how it works. Why do I do this? Why do I have my students build all these things on my servers? If you want to cook dinner, how do you cook something for which you don't know what it is that you're cooking? So I have all my students build everything, including their own cloud. And when they build their own cloud, they learn how the cloud works. Do it with me, do it on your own. That's what's necessary to become a solution architect. You cannot get hired by just doing certifications. It's not part of it unless you're very lucky, or if you're like me and you've got 20 some years experience, sure, you can get hired. But the certifications alone are only 10% of the process. The certifications will get you the interview, and that's what we teach them. They help you get interviewed, but they do not get you hired. I hope I answered your question there. Tayi, basically that's how you build your career path. And is the DNS associated with the primary switch to the secondary baseline in case of failover? It definitely fails over, basically by what's being pointed to what, so you don't really have to think about that too much. Okay, let's go back to training and let's go talk about the VPC. So let's talk about what is a VPC. Actually, my team has asked me this message. My team has actually asked me to basically ask everyone to like or subscribe and hit the bell, as well as if you like this information, please feel to text others and share it with other people so that we can help them as well. Now we're going to go to this. Pistol grip vlogs, I guess we could ask you one more time. To what extent do you need to develop your own cloud? You need to understand every component of what the cloud is and how each and every component works and how they work together and how everything works. If you can learn that on your own, great. If you have to build a cloud like we do with our students to learn it, great. Understand as a cloud architect, you're not only going to work on the AWS cloud, you're not only going to work on the GCP cloud, you're going to work on hybrid clouds, meaning organizations that are running their own clouds, like the OpenStack Ansible cloud that we teach people. You're going to be working on the Nutanix cloud, you're going to be working on the Oracle cloud, the Google cloud, the Azure cloud, and the AWS cloud. So do not pick a specific service. Learn how everything works, and then it's super, super, super easy to pick any cloud. All my students can work on any cloud, anywhere, anytime. Now, let's talk about the VPC. The VPC, organizations typically call of it as a virtual private network. I like to look at the VPC as your virtual private data center. Why do I consider the VPC to be your virtual private data center? Because it's more than a network. All your stuff, your servers, your storage, all of it, it's all going to be, for the most part, in your VPC. So because of all your servers are and your databases are, they're all going to be in your VPC. And because they're in your VPC, guess what? That's part of your data center. So I consider it to be a virtualized data center and a network at the same time. What are the main components of the VPC? And we're going to talk about all of them. And this is the cool stuff because this is networking. We're going to talk about routing. We're going to talk about internet gateways. We're going to talk about egress-only internet gateways. And we're going to talk about NAT instances and NAT gateways. Then we're going to talk about VPC endpoints. And then after we talk about VPC endpoints, we'll talk about VPC peering. We'll talk about network access control lists and security groups. I will cover as much of this as I can from an architecture perspective, while understanding that we're training you for certifications right now, and there's a huge disconnect between the job and certification. I'm going to try and give you as much in reality as I can about the job, while still giving you what's necessary for the certification, because they're completely opposites when it actually comes to doing the job. Certifications are related to junior engineering positions as it pertains to, for example, architecture, which is designed for design. So I want you to understand the concept of what a routing table is. So organizations have routers. What do routers do? Routers determine the path to get through your network. That's it. You take your data from point A, it goes to point B, it probably goes through 10 routers along the way. The routers will determine your best path to get to the network. How do routers determine the best path to your network? They build a map. If you wanted to get from point A to point B in your car, you pick up a map. The old days we picked up a map and it would say make a left here, make a right here, make a left here, make a right here. The map was your path. Now we have something called the GPS. What does the GPS do? A GPS has maps. And then the GPS determines your location and determines the best way to get you from point A to point B. A GPS is a router. A GPS is a router for you, where our traditional router is a router for your packets, which we talked about the first day. We talked about the OSI model. Routers move packets at layer 3. How does this stuff work? Routers build a map. What is the map called? It's called a routing table. So this is the way it typically looks like in a routing table. And with AWS, it's not like you call Cisco and you put a big router in your thing. Remember, it's a VPC. It's a virtualized network in a data center. That's all the cloud is. It's a virtualized network in a data center. Why is it near impossible for people to take certification exams to get hired as cloud architects? If they don't know the network in the data center, they can't possibly design a cloud solution. You want to be a cloud architect? Learn the network in the data center. That's the job. Just virtualize. So what does the network look like? You get a routing table. What is the routing table? It's a map. So let's look at this particular map that I put in front of you. Let's presume I'm a router with 4 arms or interfaces. I know that 172.16.1.0 is in my routing table. Why? Because it's local or it's directly connected, meaning it's a subnet configured on the router. Now, if I want to go to this class B, or I don't want to call it class B, but if I want to go to this /16, 192.168.0.0/16, I know to get out my interface, PCX 1234556. That's the way I reach this destination. And I now know that if I want to get to 192.168.1.0/24, go out this arm. It's a different destination. Now, does the 192.168.0.0/16 include the 192.168.1.0? The answer is yes. This is the 192.168.1.0 is a summary, 0.0/16 is a summary route, and the 192.168.1.0/24 is a more specific route. Routers will choose the more specific path. Here is what I mean. Imagine you got in your car and your GPS says, drive to Florida. That's a summary route. Now, the 192.168.1.0 is a specific route. That says to get to Chris's house in Florida, take this route. That's the difference between a summary route and a more specific route. Routers will always pick the more specific route. The last kind of route that we're going to talk about is something called a default route. What is a default route? If you don't know where to go here. So let's say if I don't know where to go, I know how to reach Florida with the right arm. I know how to reach Chris's house with the left arm. Maybe my right foot is the place where I go when I don't know where to go. That's the default route. So routers build routing table. Now, what do these things look like? Let's talk a little bit about networking from a high level. All organizations have routers. A router is needed to connect one subnet to another subnet. In the world that I live in, you typically work within a global enterprise and they literally have 20 to 30,000 subnets. That's pretty normal. Lots of routers, thousands of routers. By the way, this stuff that we're talking about, the routing, this stuff is complex and not a little complex. This is real complex stuff. I had to read 75,000 pages just to become a Cisco certified internet expert. Compare that to the 250 pages in an AWS advanced networking book. When I talk about being an architect and I talk about being able to design, I'm talking about depth of knowledge. And that's what I train my people with. That's why I say certification is 10% of it. Guess what? This is awesome. So how does the network work? Internal to organizations, they run a routing protocol. What is a routing protocol? It's basically like your GPS. It determines the best path for you to reach your destination. What is the routing protocol? It basically says, I'm here, I'm here, I'm here, I'm here, I'm here, I'm here, I'm here. When you do that, that's what they do. That's what the network does, and things like that. So internally to your organization, you're going to run what's called an interior gateway protocol. What is an interior gateway protocol? The interior gateway protocol is something that you use inside of your organizations in order to optimally determine your best path to your destination. Internally, we're dealing with OSPF, Open Shortest Path First, intermediate systems to intermediate systems, and EIGRP, which is a Cisco proprietary one. Every organization in the entire world runs one of those three routing protocols. Now, when you connect an organization to an external organization, you use what's called an exterior gateway protocol. An interior gateway protocol is what you use inside of your organization. An exterior gateway protocol is what you use connecting to other organizations. What is the exterior gateway protocol that you're going to be using with cloud computing? It's going to be BGP. And specifically, it's going to be eBGP, which is used to connect to external organizations, while BGP is actually used for internal organizations. So while a complete discussion of BGP would be outside of the scope of this discussion, and I've spent over 10,000 hours working with just BGP, and I've spent probably 5,000 hours learning to be good at BGP, that's what it takes to be a designer and a systems architect. You guys want networking, you let me know. I will go into all the depth about networking that you understand, and our free networking content will be 10 times deeper than anybody's paid networking programs, because I want you guys to be successful. So organizations use an IGP or interior gateway protocol internally, and they use an exterior gateway protocol to connect to external organizations. Why do organizations use BGP to connect to things? Why does AWS use BGP with you? BGP is the most scalable routing protocol. It's customizable, it works, and it worked great. That's why organizations use BGP. That's why BGP is critical knowledge for cloud architects. That's why it's so essential to be able to design and understand systems. You must understand the network. So as you can see in this thing, organizations use OSPF or whatever, and they connect to external organizations. BGP is what's called a path vector protocol, and we'll talk about that in a minute and how it works and why you would use it. But understand this. Every organization that uses BGP has something called an autonomous system number. The autonomous system number identifies you and your organization. So Go Cloud Architects, if I was going to connect to multiple internet service providers with BGP, would have the Go Cloud Architects, literally speaking, autonomous system number. When I would connect to AWS, I would connect to them with their autonomous system number. So now let's talk a little bit more about it, but I wanted you to at least understand conceptually a little bit about BGP. And then Chris, I saw there was a question that came in from Taiwei. If you can take that down, we'll answer the question on the next break. So what do you need to know about BGP? Ideally, how to design it and how to tune it. But what do you need to know for the exam? I'm going to tell you. What do you need to know for the job is the kind of things that we're talking about if I do some free networking training. What you need to know for the exam is quite simply that BGP is a TCP-based routing protocol. It uses TCP port 179. So if you've got a BGP session going through a firewall, you must open up TCP port 179. Organizations use BGP to connect to multiple people so they can determine the best path routing, and that's one of those things that is absolutely essential. And BGP was basically the way it works. So in order to use BGP, you're going to need the following. You're going to have to apply for an autonomous system number if you're using public BGP. If you're not applying for if you're using private BGP, you can use one of the private autonomous system numbers, which are just like private IP addressing. There's private autonomous system numbers. But understand for this exam, BGP is TCP port 179. Understand that it is a path vector protocol, and understand that it is a dynamic routing protocol, meaning it learns routes automatically instead of you manually configuring static routes, and understand that it's the only routing protocol that you actually configure when you deal with AWS. BGP is required when you're using direct connections. BGP is optional when you're using VPNs. When you're using Cloud Hub or any of these things, BGP knowledge is critically important. So BGP is a critical skill for cloud architects, and therefore we talk about it a lot. My students in our training programs get extensive networking background because networking is critical for cloud computing. I try to do the best I can for free in the community because I want to make sure that we help people, but our students obviously get some really exceptional internal training on these kind of things. So that's the way we do it. So let's go back into some more BGP because I love BGP and I love talking about BGP. So BGP is a dynamic routing protocol. You have two options when it comes to routing. I can point you and say, to go to this subnet, go out this link. I can manually configure that. That's called a static route. Great. Now what happens when I need another route? I have to manually configure it. When I need another route, I need another one. And when I need another one. Now, let's say I have two links, both links, and one link goes down. I'm not doing anything. With a static route, they're not going to heal themselves. So dynamic networking is really essential to building high availability, high performance systems in the cloud or off of the cloud. So when you connect with them, you're going to use them. BGP has a tremendous number of tuning options. Tuning options like you can, which I'll talk about in a minute, enable you to influence path selection. And there's a concept of taking in your routes and taking out your routes. Understand that AWS does support the community no export. What is the community no export mean? Let's say you've got three people, or you've got internet service provider, 1, 2, and then 3. I don't have enough hands. So maybe if I take a phone and I don't have enough hands. But let's just say if service provider A is Chris, service provider B is me, and service provider C is Balwinder, if I send my routing information to Chris, and then Chris sends my routing information to Balwinder, all of Balwinder's traffic and everybody else that connects through Balwinder will then be coming through me to reach the ultimate destination, which can be very dangerous, which means when you're using BGP, if you don't understand it and you don't understand the concept of no export or route filtering, what can ultimately happen is you can make the entire internet's traffic go through you. This is why organizations say they need experience. They don't care about experience, they care about competency. If you're not careful with BGP, you can instantly make the entire internet go through your environment, which means it will fill up your network, it will create a DDoS attack on you, it will cause auto-scaling, which will cause you to spend millions of dollars in a matter of 2 hours, and you're still going to go down. So BGP knowledge and tuning is absolutely critical. How do you influence the path selection? Well, BGP, like all other algorithms, have a decision process. And I know this is extremely complex, and I know we've covered something that could take 5,000 hours to learn in 20 minutes. So if you're a little confused, my apologies. It's just I want you to understand how much you need to know. And if you really want to learn a lot about BGP, you can be one of my students and you'll learn a lot about it. And if you don't want to be one of my students, you can read the book Internet Routing Architectures by Sam Halabi, or he sometimes goes by Bassam Halabi. That is how all of us learn BGP. That plus the request for comments. It's mandatory reading for all CCIEs. So realistically speaking, that's the way BGP works. Direct connection, how do you influence weight? You can change the weight. So BGP prefers the path with the largest weight, then the largest local preference, then the shortest AF path, then the lowest med, and etc., etc., etc. With BGP, you are definitely able to influence the path selection. and definitely, that's how you do things. Now, when you're dealing with AWS and BGP, you're dealing with a really weak, limited BGP implementation. When people like me connect to 10 different service providers, we're taking in 750,000 routes from 10 different internet service providers. So our routers and our routing tables, literally speaking, have 7.5 million routes in them in the rib and things like that. Now, when you're dealing with AWS, they limit you to 100, which is nothing. Nothing. A big global enterprise is 30, 40, 50,000 subnets. So, is it critical to understand networking with AWS? Sure. Do you have to know how to summarize all your routes? Absolutely. Do you know how to do your route filtering? Sure. You need to know all of this to be able to move forward. Now, I don't know how much time I spent on BGP, but understand BGP is this path vector exterior gateway protocol that uses TCP port 179. All networking in AWS is done via BGP. BGP is used for scalability, BGP is used for performance tuning, and BGP is how you do things. Now, I saw 2 questions pop in, and we're going to talk about internet gateways. I probably gave a lot of you guys headaches with regards to BGP, so I'm going to give you 3 to 5 minutes of questions, then I'm going to answer 2 questions, and then we're going to get back into the fun talking about internet gateways, things that are going to be much more normal for all of you. Remember, I have 10,000 plus hours in BGP, and you guys all said you want some networking. Students in my program will get the ultimate networking experience, but I will make sure that I provide some good free training on the internet to teach networking for cloud architects. I'm going to answer these 2 questions. Alara C, if we enroll in your architect program, are there any online classes in place for students apart from the recording? Here's the way my program works. We have 2 live training sessions twice per week for 3 hours. During these 3 hours, we do architecture work together. There are lectures, there are training. We focus on networking, security, the cloud, and architectures. We do this live twice per week, which means the average student that goes through our program gets up 100 hours of live instruction with us where they can ask questions. Video recordings are not how you become a cloud architect. That's part of it. So about 100 hours of live lectures. We also have about 100 hours of pre-recorded lectures that cover everything from networking to passing your exams, how the cloud works, what is the cloud when you're done. Then we have our students, realistically speaking, build the cloud, build all the technologies that build the cloud, and then our students do case studies to design things for real. That's what we do in your program. That's what we do in this program, Alar. So if you've got other questions, you can ask me, you can ask after that. My team is Balwender. The name of the book is Internet Routing Architectures by Bassam Halabi. So if you're interested in our program, here's a coupon code for 20% off. And my team hates when I do this, and they told me this is the last week I'm allowed to actually do this. They're moving me to a different phone number. Here is my phone number. If you have any as a backup phone number, this is the last opportunity to get my personal phone number because we've grown too much when we do these kind of things. So that's how you reach me. Now the last question before we move on is from Tayi. Would the GCA course prepare you to pick the Solutions Architect Professional? Yes. That is literally 10% or less of what we cover in the course. I'll tell you, of course we cover that, but that's minimal. That's 10 hours of our 250-hour program. The other 240 hours are based upon the things that are necessary to get you cloud architect hired, make you capable, make you competent. The Certified Solution Architect Professional is a bare minimum, and that's it. The rest of the other things are important. Now let's get back to training, because I didn't like to default for too long, but I figured I gave you guys all a headache. And Ramya, it looks like you've got a couple of questions that you're posting constantly. If you send an email to this email address, Ramya, because it looks like you have 2 or 3 questions that are deeper questions and we want to help you, send an email to that and someone from my team will reach out to you with the exact thing. I believe it's 7 days. But you can check the AWS webpage or you can reach out to us and someone from our team will actually give you the exact answer. But we're still going to check the AWS webpage, and the reason we're going to check the AWS webpage is as follows. These things change constantly, and just because something was published in a book 6 months ago, the one in our book, it could have changed since then, so we were going to recheck the webpage. That information is contained for free in our free books, but we will double check it just like we would check you. Whenever we do an architectural design, we always go back to the site to make sure nothing's changed, because these things change all the time. So that's what we're going to do when we respond to you. We want to make sure we give you perfect, completely accurate answers. So now let's go back, now that we're done talking about dynamic routing with BGP, let's talk about what an internet gateway is. So we're going to talk about lots of different kinds of internet access. So internet access can be one of a couple types. Internet access could be just going out to the internet and letting your return traffic come back, or internet access could be basically allowing your systems to be exposed and available on the internet, like for a web server. So we'll talk about the ways that you can actually do these things in your environment, which is cool, and I always love talking about these kind of fun things because connecting to the internet and the network is just cool as far as I'm concerned. So an internet gateway is the way that you provide what I call true, real internet access. So in a normal data center, what you have is you've got a router that has a connection to the internet, and the router that connects to the internet is your internet-facing router, which some people would call a gateway. A gateway and a router are interchangeable terms. So what does a normal organization do? They have a connection to one or two internet service providers. They got a router there. Everybody gets pointed to those things. That's how organizations do things. How do you do it on the cloud? Same way. Instead of basically setting up your connection and running BGP to your internet service providers, you just configure an internet gateway. Guess what? How easy is it to remove the 10,000 hours of BGP knowledge for internet routing architectures and just set up an internet gateway? Super easy. Now, to do all the tuning, the traffic engineering, the architectural design I'm talking about to actually be a true cloud architect, that takes knowledge. But to set up an internet gateway, no big deal. Basically, all you do is you're going to create an internet gateway, which is going to be an AWS high availability virtual router. That theoretically it has no bandwidth limitations or performance constraints, and it's just a router that connects your systems to the internet. Now, when you use an internet gateway, understand your systems are fully exposed to the internet, which means they are hackable, easily hackable if you don't do something about it. How you do it? You basically attach an internet gateway to your VPC. Then you create a default route and you send all traffic to unknown destinations to the default gateway. So basically you place a route in the routing table of your VPC and it says all unknown traffic go to the internet gateway. Why is it unknown? If you don't have a route to it, you're going to use the default route. The default route is going to send your traffic to the internet. So you're going to attach an internet gateway. You're going to create a default route. You put a public IP address on the system that needs to be accessible. We'll talk about what those are later throughout the things. And poof, your systems are accessible from the internet. Now, I just said your systems are accessible from the internet. That means they are open to hacking. This is full bidirectional internet access. Out, back, in, out. Internet gateways, just like an enterprise environment. Really cool stuff. What does it look like in all practicality? How's it going to work? It's going to work as follows. You're going to have your compute instances, which are going to go to the router, which is in this case the virtual router for your VPC. The virtual router is what we're talking about. And after we talk about the virtual router that we're talking about, then we need a default route to the internet gateway, which is going to point to the internet. So how does this all work? We basically have our servers. Assume the servers are sitting behind a load balancer, and the load balancer has a public IP address on it, as you can see, the EIP or the elastic IP address, connects to the instances, which then connect to the router, which then go out and connect to the internet. That's the way this stuff works. And you can see in the routing table, you're going to see a default route, 0.0.0.0. What that means, if you don't know where to send your traffic, send it to the internet gateway, and now poof, you've got a fully functional, operational, bidirectional internet access, which again means your systems are reachable from the internet. What does this mean? It means they can and will be hacked unless you do a lot about it. And when we talk about security, as part of our discussion, we're going to get it pretty deep in the security. We're not going to just stop at what's on the Certified Solutions Architect Professional exam. We're going to talk about security because it all matters. So now let's talk about egress-only internet access. And what is egress? Ingress means coming in. Egress means going out. Ingress come in, egress going out. So let's talk about what this actually means in the context of what we're talking about. So egress-only internet gateways. Now these are designed for IPv6, but there's a version that we're going to talk about for IPv4 with a different name. But egress-only internet gateways basically are like, I can go out to the internet and my return traffic is allowed back. I can go to the internet, my return traffic is allowed back. No one from the internet can come in and reach me. Sound like a firewall kind of environment here going on? An egress-only internet gateway allows outbound traffic and return traffic. Now, AWS calls an egress-only internet gateway. They use the term for IPv6, they call it an egress-only internet gateway, and they use the term NAT gateway for the same concept when it comes to IPv4. An egress-only internet gateway allows inbound users out and the return traffic, but it keeps all external users blocked. They're not allowed in. So egress-only internet gateways, if you're using IPv6, are the perfect way for your systems to basically come up, maybe upgrade their packages, download software, download updates, but they are not reachable on the internet. So this is a great way to basically provide internet connectivity for your needs. And at the same time, not only does it provide internet connectivity for your needs, your systems won't be hacked this way because they're not completely allowed. So perfect way to patch your systems. Now, while we're talking about all these types of egress-only internet, though AWS doesn't use the term, the other option is you could use a NAT instance. And what is NAT instance? It's another way to do NAT. What is NAT, or network address translation? Network address translation is when you take one address and you translate it into another address. NAT does not mean connecting to the internet. NAT means translating one address to the other address. It's one of the ways when I interview cloud architects if I can determine if they're hireable or not. If I ask a cloud architect candidate, what is NAT? And they say it's how you connect to the internet. It means I know they passed a certification exam, but they have no knowledge of networking and no knowledge of the cloud and no ability to hire them because they won't be able to design. Now, if they tell me NAT translates one address to another address, and they say some use cases could be an organization versus another organization that has overlapping IP addresses, and they can use NAT to translate it. NAT can translate your private IP addresses to public IP addresses when you're dealing with connecting to the internet. NAT enables you to connect to external organizations that have overlapping IP addresses. Again, that's the way to help you connect to the internet. And these kind of things are how I can assess if someone understands NAT. What is a NAT instance? A NAT instance is a custom EC2 instance in AWS that will translate your private addresses to a public address. That's it. So how would you set up a NAT instance? You basically take a NAT instance. First, you would set up an internet gateway. Then you would take a NAT instance, and all your devices would have a default route to the NAT instance, which would then point to the NAT gateway, which then connect to the internet gateway, which is pointing to the internet. Again, this is egress-only internet access. AWS does not recommend using NAT instances in today's world. They recommend using NAT gateways for IPv4. It's a much simpler and more elegant solution and a cheaper solution, so we don't recommend NAT instances. Just understand a NAT instance translates your public address to a private address and you point it to the internet gateway. Now, understand that NAT translates a public address to a private address, or a private address to a private address, or one address to another address. So if you're ever asked on a job interview, what is NAT? Network address translation translates one address to another address, and you can talk about the use cases, such as connecting to the internet, overlapping IP addresses between partner organizations, and an organization who purchases a new company that's using overlapping IP address space. Now you know what NAT is, and NAT instances are. So egress only internet gateway, outbound only, and return traffic back for IPv6. NAT instance is the old way to do egress only internet traffic for IPv4. The new way to do egress only internet traffic for IPv4 with AWS is to use something called a NAT gateway. A NAT gateway is a device that provides egress only internet access for IPv4. Again, what do I mean by that? You can go out to the internet and you can come back to collect your packet, and your return traffic is allowed out, but external people are not allowed in. So because of these things, understand that with a NAT gateway, it's for IPv4 data only. How does this work? So basically, normally speaking, you would need redundant routers to do NAT, or redundant firewalls. AWS does not really give you the ability to produce a physical firewall, but they're dealing with logical devices. And since their logical devices are created by them and they're extremely high availability environments, a NAT gateway provides a great way to connect to the internet and allow your return traffic to come back to you. So how does this work? The NAT gateways, like I said, they're highly available devices and they're going to be redundant inside of an availability zone, which means you don't have to worry about a single point of failure per availability zone. But like I told you with high availability, 1 is none, 2 is 1, and 3 is greater than 2. You need to put a NAT gateway in every availability zone you have. So you set up a NAT gateway. It's going to be created in a public subnet. It's going to have an elastic IP or a public address for the life of the gateway. How do you do this? Every device gets a default route, meaning if I don't know where to go to the NAT gateway, the NAT gateway is connected to the internet and that's it. So it's much simpler than a NAT instance where you'd have to create a NAT instance and point it to an internet gateway. That's why this is the simple and highly recommended solution. Elegant solution. I actually think AWS did a beautiful job with this. You know me, I'll say cloud great here, cloud not great here. Elegant, 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 easy way to connect to the internet. Basically, you've got your users that are sitting in your private subnets. They all have a default route to the NAT gateway, which is connected to the internet, and everything works. So let's talk about network interfaces and IP addresses, and we'll try and make some of this stuff a little more clear for you. And realistically speaking, so when we're talking about creating a network interface and what this kind of network interface actually is, what's going on here is you're connecting, so let's look at it this way. I'm trying to explain this in a way that's going to be simple. So let's say you have a server and it's got 4 network cards. They're 4 network interfaces. Every network interface in your server needs to be on a different subnet. And why would you do this? You might want a system on 2 subnets. Basically, you might want to improve the routing between them. You may want to segregate things. You may allow one subnet access to certain things and another subnet access to different things. So there's lots of reasons you would what's called dual home, which is basically where you put a server on multiple subnets, or multi-home, which is where you put them in a lot of them. It's also used for something called the bastion. So you might also use two network interfaces to create a bastion host. A bastion host is one of the worst ideas you can use for management and security. So we don't recommend it. We recommend better options whenever possible. But if your organization doesn't necessarily have the sophistication or the desire to do something better, that's why they teach bastion hosts at the junior levels of these architecture courses. Not a great option, but like for example, a bastion host would be, you could SSH to a box that's sitting on the internet on one interface, and it's got a security group protecting that interface, and then on behind the interface you have another Ethernet port which could go to the web server subnet. Pretty horrible way to do it compared to other options, but if you don't have VPN access or direct connection access, this might be your only option in certain cases. So that's why people create these bastion hosts. But an elastic network interface is just a network card. You need a server with 2 network cards? You add 2 network interfaces. What do you do in AWS? You add 2 elastic network interfaces. That is how you set this up. Multiple interfaces, multiple elastic interfaces. So by default, when you launch your system, it has an elastic network interface and it's going to be ETH0. But you can create additional network interfaces so you can understand how that works. Now, that's how you create each interface, and each one needs to be on a different subnet. But, what if you needed a public IP address? How do you get a public IP address? Well, typically speaking, you got to deal with your internet service provider. You got to get a registration. You got to get there's all kinds of processes, typically speaking, to get a public IP address that networking people like me have gone through for the last 25 to 30 years. But with AWS, it's easy. If you want a public address, you just borrow one from them for as long as you need it. This is, again, one of those elegant things in the cloud. So an elastic IP address basically is an address that you borrow from AWS. That's a public address that you keep as long as you need it. AWS maintains a pool of addresses, and they lease you addresses, which we love. Lots of people, lots of addresses, and this is the kind of thing. So I want to create something. I need a public-facing address. I go to AWS. I pull an elastic IP address. I use that elastic IP address for a month, a year, 10 years, whatever it still needs to be. And after that, everything's connected to the internet and everything. I've got my address. Now when I'm done using that address, maybe I create a new business, maybe I move to a new cloud, go back to the data center. Who cares? Close the business. From there, that IP address, the external IP address, the elastic IP address gets returned to Amazon, and it can be delegated to another customer. We find this solution at GoCloud Architects simple, elegant, and we absolutely love it because it removes a lot of the complexities that many of us have dealt with for so many years. So we'll call attention to things like we want. Shankar, a bastion host, is a jump host. It's kind of a horrible solution, but there are times people use it if they didn't design their systems right. And Arag, a NAT gateway does not need to be connected to the internet gateway because it's got it included. And a NAT gateway can't be stateless, cool dude 5699. And the reason a NAT gateway can't be stateless, it has to be stateful. It has to know to allow you return traffic back in. So it needs to see the state of your traffic, otherwise it wouldn't know how to let it back in. So don't think stateless whenever you're dealing with firewalls or anything that allow one directional traffic. They have to be stateful. We can talk about that if you guys desire at the next break, which we'll do in a minute. But here's the way it actually looks like from an elastic IP address perspective. Let's say you've got your compute instances and you need a public-facing IP address. You could place it on a single compute instance. You could place that elastic IP address on the load balancer that precedes them, which is typically what you would do. But you need one public IP address or an elastic IP address. That will have a route to the internet gateway, and poof, you'll be on the internet. I'm sorry, this shouldn't be. This is for internet gateway, and this is how you would make your web servers reachable from the internet. Got your servers, you got a public IP address on something, either the load balancer or on a server. We can talk about those architecture choices later. Then you've got a route in the routing table to point you to the internet gateway, out to the internet. Poof, Bob's your uncle. Everything's running, and you are completely 100% connected to the internet. Now, some of these concepts are a little challenging, and I want to open it up to some questions along the way to make sure that you guys aren't stuck. I don't like take training courses when nobody answers my questions. So if you've got any questions, I'm going to do what I can to answer them for you right now. Do we have any questions on the last things that we've covered on the networking side? I know there's a 30-second delay or so, which is why I'm doing that. I'm waiting to see if any of you guys have any more questions. If you don't have any more questions, what I'm going to do is I'm going to go back to the training program. Okay, so great question. So here's when you would use a Bastion host. If you designed your network very poorly, or a jump host, and you didn't have any way to connect to the cloud, what you would do is you would SSH to a publicly facing web server, and mind you, high security environments don't allow SSH. So just think about that ahead of time. So you would SSH from your computer to the Bastion host, which would have 2 network cards, and then you would leave that Bastion host, which is publicly exposed all over the internet and not completely locked down or secure, but it's the best you can do. And then you would go out that part to the Ethernet port. By comparison, if you wanted to design the architecture correctly, you would create a VPN access between your organization and the cloud. And with the VPN that you would have IPsec encryption, which is much, much, much stronger than SSH encryption. And you would be connected to the cloud. And if you further wanted to improve your security, you would just ride your direct connection and go to the backend management interface and not deal with any of these jump hosts. The jump hosts are a workaround to poor network design. So use your VPN connection to manage your systems, use your direct connection to manage your systems. If you set it up without that, then you've got no choice but a Bastion host. But if you can avoid this, this is poor design. You don't want to do it. It's only if you don't have internal access to your systems that you would ever consider violating your security in such a bad way like a Bastion host. I know there's some cloud providers or trainers in Australia that recommend this, but we don't recommend this. This is not the way we would ever design an architecture that matters. We've consulted with the largest banks, healthcare organizations, and service providers throughout the world. They have not. This is the way everybody does it in the entire world. The Bastion host is a workaround to a bad situation. A Bastion host would be perfect for a very small company that have 5 or 10 employees that basically don't have a full-time connection to the cloud, that they want to manage their externally facing website. But that's not necessarily something we would ever recommend you do. Can you set up something the way the diagram looks there, Joe? Of course you can. Instances are for scaling and running different apps. Well, in this particular case, the instances were web servers and probably should have had a network load balancer or an application load balancer directly in front of them based upon the needs of the organization. But yeah, of course, Joe, you can build any of these things on the cloud. Any other questions before I go back to the next topic, which is endpoints, which can get pretty ugly, but we're going to do it anyway? going to do this. I was notified by my team that I should paste a link to our course, which I highly recommend. I've been helping people get their first tech jobs for over 20 years now, and people in my program are doing fantastic. 10% of them haven't even completed the program and are already hired, so I view that as great success, and they still have a lot to go. Anurag, are you saying Bastion host in a hybrid environment will cut off this? So I am saying that the only time you would ever use a Bastion host, Anurag, is if you didn't have a means to connect to the cloud environment like a direct connection or a VPN connection. That would be the only time you would use a Bastion host. Otherwise, you would connect to your servers directly through your direct connection or directly through your VPN connection. Why are you using a Bastion host? The only reason anybody in the world would ever reach a Bastion host is they don't have any reachability to their servers. So they're creating something on the internet so they can go from the internet to their servers. Why would you ever go to the internet to connect to your servers? You can just connect directly to the cloud through your direct connection in your private environment in a higher security environment. Or you can connect to it over the VPN, which is encrypted via IPsec, which has much more security than SSH. Did I answer that question in a manner that you actually understood before we move on to the next topic? Because it's very important. I want to make sure that we answered your questions before we move on, and I know there's a 30 to 45 second delay. So if you guys have any questions there, I'll let you. Okay, so I saw you responded. I think that's great. Any other questions here before I move on to the next topic of endpoints? Cool Dude 5699. Of course, we have a professional exam guide. It's included at no charge for our students in the program, along with 250 hours of training. Absolutely. Again, an Open VPN Act server is something that you could use K1, but SSH-based VPNs are considered low security compared to higher security solutions. So you would only use Open SSH VPN if you have no choice. An IPsec VPN is a much more secure option. In fact, high security environments actually disable SSH. And in the Google Professional Cloud exam, they actually say you've got an organization that needs to secure. What will you do when they want to know that you disable SSH? So we don't use Open SSH for anything other than for testing and exploring purposes. We use IPsec and we use direct connections. People that are going to pay you as a cloud architect need to know that you are really locking down their systems. If you've noticed, there's like 50 hacks every day on the AWS cloud, and usually due to misconfigured AWS buckets. But all these problems are coming from violating security principles that we've all learned for 25 years not to do. Bastion host is one of them. SSH VPN servers, most of us haven't used that for well over 10 to 15 years because of the security vulnerabilities. So it could be done, but in our program, because you're with us, K1, I know you're going to learn the better ways to do it with IPsec or realistically speaking, direct connections. That's why we don't use Bastion host. I come from a world where we design systems for banks, healthcare systems where it really matters, where breaches will cause organizations to go bankrupt. And anybody that's going to pay a cloud architect $300,000 a year needs to know that their systems aren't going to go crash. So they need much greater levels of security than the kind of things like a Bastion host. That's why we're covering the things. I'm going to give you the kind of knowledge that you'd know to be an architect as opposed to just an implementation engineer. So let's get back to the content. Let's talk about endpoints. So what is an endpoint? An endpoint is a way to basically connect from one service to another service over the AWS cloud in a secure manner. So endpoints, by using endpoints, you improve your performance, you improve your security, you reduce your latency, and you lower your cost. Let's look at what life would be like for an endpoint without it. Let's say you wanted to connect to S3 over the internet. You can. Basically, you'd go from your VPC, your NAT gateway or internet gateway, whatever you have, cross the entire internet and go back into AWS S3. This will work perfect, no problem. The only problem is, Chris, please take down Pistol Grip's question. I'll get back to it soon. So if you leave your organization, you go across the internet back into S3, you have two problems. First, Amazon charges you for your traffic data that goes in and out your internet gateway traffic. So you're going to pay high fees. Secondly, as we discussed yesterday, internet performance is not guaranteed. It's what's called best effort, which means when your data goes to the internet, there's no guarantee that it's delivered and there's no guarantee of performance. So you try to always use your own network backbone anytime you got it, as opposed to using the internet, because internet performance is low performance, higher latency, and you have no guarantee that it's safe. So whenever possible, you'd want to ride the private network. So looking at this example, you could connect in an expensive and poor performance scenario. You can go from your VPC to the internet back into S3, or you can connect your VPC directly to S3 and ride the Amazon network, which means guaranteed performance, guaranteed bandwidth, and lower costs. So an endpoint is a way to basically connect your service, your environment to another service in a high performance environment by sending your stuff over the AWS network, not the internet. So it's cheaper and it's higher performance. You can't guarantee anybody's performance off of your network, but AWS can guarantee the performance of their network. They can use QoS policies. They can use RSVP signaling to make sure you've got enough bandwidth on the links before they send your data and create virtual tunnels. AWS has the capability to do this. AWS can do this, so riding the AWS network, always, always, always much, much higher performance, and it's cheaper. And when you can get better, faster, and cheaper in tech, you always choose that option. So since you know endpoints are a way to basically connect to certain things over the private network, let's now talk about what that actually means, what it equates to. So an endpoint is a virtual device. Like everything else in AWS, it's just a virtual network and virtual data center. That's why I say to be a cloud architect, you got to know the network and the data center. There's no other option. And virtual devices are basically a place that you're going to connect to. And they're high available, they're virtual, and what do we mean by this? There are going to be two kinds of endpoints that you can connect to. There's going to be a gateway endpoint, and there's going to be an interface endpoint. And we're going to talk about how they work. Endpoints are a way to connect to an external service or a different service over the AWS network. So gateway endpoints and interface endpoints. And we're going to talk about the benefits of each and why you would use some. So a gateway endpoint is the means that you connect. It gives you high-speed access to an AWS service. And the way it's going to do this is going to place a route in the routing table that says to get here, go here. So it's going to use routing to basically push the routing to the gateway endpoint. Typically speaking, your gateway endpoint is for Amazon S3. And what it's going to do is it's going to allow you access S3 in a secure manner from your VPC. Basically what happens is you're going to create an endpoint where you're going to create a prefix list, and the prefix list is going to basically show you how to reach the endpoint. And the prefix list will adhere to the naming convention. It's going to be a PL dash and then some information. And it's going to look like something like this in the routing table. I want you to see what it looks like. So basically I'll pop what the prefix routing table is going to look like. It's going to look like something like this. So that's what you're going to see in your routing table. Now what does it all look like? Here, I'll show you. When you're dealing with a gateway endpoint, basically what you can see is, let's look in your VPC. In your VPC, you can see you've got your VPC endpoint to an elastic bucket. Now what we actually did here, which is something that I find very cool, is not only we connect your VPC to an S3 bucket via the endpoint, which we did, but what we actually did in this particular environment is we connected the data center to the cloud and the VPC endpoint. So by doing it in the manner that we can, a user can literally go from the data center and they can request data from sitting in an AWS S3 endpoint and pull it back, or I'm sorry, they can be in the data center, request content from an S3 bucket, and literally ride the VPN connection or the direct connection back to the data center in a highly secure, high availability manner. So I'm going to go back to this again. Gateway endpoint, high speed, high performance, private access, and secure access to S3, places a route in the routing table, and guess what you can actually do? You can actually push that data, because it's a route in the routing table, to the data center, and it'll be reachable from your data center as well. So we love this solution. It's an extremely, extremely elegant solution. Let's talk a little bit more about the gateway endpoint as it pertains to security. What you have to do is you're going to set up an endpoint policy to make sure that you limit the resources to who can access it. Because if you don't want certain people to access it, don't do it. Here's the thing. Network architecture people like me know security, and the reason we know security is as following. Let's say I wanted to go to someone's home. If the destination between me and someone's home is all desert for 400 miles, there's no roads, I can't drive my car there. If it's all desert, I might not be able to walk there if it's a couple hundred miles away. I can't get there if there's no route. So we people know that in routing, and that's what all security starts with the network. If you don't have a route, you can't reach it. And guess what? If you can't reach it, you can't hack it. So endpoint security is basically about limiting who has access to the routes coming from the routing table. You can do some route policy things, limit the routing. No one can reach anything if you can't have a route to it. So long before you get to IAM, long before you get to your access lists, don't provide routing information for subnets that you don't want reachable, and then they're not reachable. So that's what we're going to talk about, the gateway endpoint thing. I've been reminded by my team that I should ask you guys, if you're enjoying the content, to like. If you're not a member, subscribe and hit the bell so you can be informed of new free training when we do it. If you can do that, great. Thank you so much. Otherwise, let's get back into the training here. Now let's talk about interface endpoints. So we talked about a gateway endpoint, which places a route in the routing table, which basically is how you connect to AWS S3. By comparison, an interface endpoint is a little bit different. It enables you to connect to other AWS services, such as EC2 Systems Manager, Kinesis, and Load Balancer APIs. This can also be used by external services hosted by AWS partners or customers in their own VPC. So interface endpoints are a great way to connect to other organizations in a secure environment. Well, I told you a gateway endpoint placed a route in an routing table. Interface endpoints are a little bit different. They basically created an endpoint and it's going to look and feel local to the VPC. The way it works is you create an interface endpoint and it creates this elastic network interface in your VPC. So it creates a route, a network card, and it gets you to the VPC. And interface endpoints are just an elastic network interface. So when you create this kind of thing, when you create this kind of environment, what you're actually dealing with is a network attached card inside of the VPC. So that's how you create an interface endpoint, and you're going to specify the interface to the endpoint. When you create the endpoint, AWS will generate a DNS specific name that's going to connect you to this service. So, you Wiki, I hope I answered your question is now. So let's talk about what happens. So when you set up these interface endpoints, it places a network card that's actually sitting, it places a network interface in your thing, and a private link connection is created. A private link is a way that you send your traffic between these two organizations. A private link is similar, but different to VPC peering. And because of that, we'll explain what we mean by that and what it actually looked like. But basically, a private link is created, which is going to create a virtual private line, like a virtual direct connection over the AWS connection. And it's going to literally restrict all communication between the network interfaces on both sides of the connection. So interface endpoints or private links are a wonderful, wonderful way to restrict traffic between AWS, your VPC and AWS services, or your VPC and a partner organization. So that's exactly how it works. So now let's look about what this actually looks like going on from an architectural perspective. So let's say you've got two VPCs here. You've got a VPC 1 and a VPC 2. You could do VPC peering between them and communicate, or you could do private link. Now, private link in many cases is a more elegant solution than VPC pairing, and we'll talk about how and we'll talk about why. But these are the ways that you could have two VPCs communicate with each other. Basically, we've got an endpoint on both sides, and that's how we're creating. Well, in this case, we have an endpoint on one side because VPC pairing, private link can enable you to do unidirectional traffic, and we'll talk about that in a minute. It's different than VPC pairing, but the concept is absolutely the same. A lot of people are asking about the class, so I'm just basically going to do this. I'm going to copy the link to the class, which is starting right now, and because I see a lot of these things coming in, as well as a coupon code. You guys can click the link, and then you can see the cost of the course. So I can stay out of that and still teach. And oops. Okay, so I got to stop cutting and pasting. It's not my strength, but. Okay, so let's now talk. So I told you that VPC pairing could enable two VPCs to talk to each other, and that's great, but you can also use private link. Why am I excited by private link? VPC pairing, when you connect two VPCs together, everything is exchanged. You basically promoted full connectivity and exchange of information, which means now you got to lock your systems down and deal with IAM and filtering and all kinds of things. But when you do VPC pairing, everything is exchanged. Which means if you need full access to two VPCs, your option is VPC pairing. Now, what if Go Cloud architects needed to connect to another organization's? Let's say you have basically Go Cloud architects wanted to connect to something, and all I wanted to share with people is my server access for my students. I didn't want to share any of my accounting information. I didn't want to share any of my finance information. I just wanted students to come in from the cloud and be able to work on my servers, build a cloud, and learn to become great cloud architects. I would use private link because private link allows access to a very specific service only. So VPC pairing, everything. Private link is being used when, for example, you want access to a single service. So it's very elegant and it's very secure. What also makes this so cool is VPC pairing, you can't deal with that many of them. You can deal with 125 connections, which is nothing. But private link is much more scalable. The scalability limitation is in the thousands, and it's based upon how fast your load balancers can scale and how much your servers can scale. So absolutely, we can do these kind of things. So VPC pairing, you're going to have to get careful. You're going to have to do some route filtering. You have to really set up a policy. Whereas private link, by default, straight out of the box, only allows access to a single thing. So private link gives you more scalability with regards to route. Private link gives you much more scalability with regards to the services. Private link is more secure by nature. Now there's some other things to remember about private link, which is different than VPC pairing. And here's the thing. Private link uses NAT. So almost everyone in this environment that's using NAT, or every organization for the most part uses the same RFC19 private IP address space. Because everybody's using the same RFC19 private IP address space, then organizations often have overlapping IP addresses. Because organizations have overlapping IP addresses, they can't talk to each other. So organizations, typically speaking, would need to use NAT between them or use public addressing. Private link automatically uses NAT because it automatically assumes your IP addresses are configured. So private link basically makes it work with overlapping address space. Theoretically, you could use NAT and VPC pairing, but AWS does not support VPC pairing with overlapping IP addresses, and they don't give you lots of customization in the NAT, so it gets real ugly. So private link is a fantastic way to provide unidirectional, highly secure access to the environment. Now I mentioned private link is unidirectional, meaning it's only in one direction. VPC pairing is bidirectional. So if you want something going in one VPC and you want private communication, I could allow access to just ingress into my services. Or I could create a second private link connection to have bidirectional communication. You get that much, literally that much customization and flexibility with private link and more scalability. This is cool. It's really great. Again, I'll tell you when the cloud's good. I'll tell you when the cloud's bad. Absolutely, it's a perfectly good situation to make things work. I absolutely love private link. I also like VPC pairing. This is a great way to ride over the AWS network in a low-cost environment and a highly secure environment and have excellent, excellent performance. So private link is a fantastic solution. Now, there is another option. Let's say you're an organization that provides services to a lot of other organizations. Now, this is where the cloud shines. The cloud is a reduced functionality network and data center with much lower performance. I can get 10 million IOPS on a server in my data center. I can get 64,000 IOPS in the cloud. You're not even in the same universe. I can get much lower latency in the cloud. I can get into the millisecond latency in the data center. I'm dealing with 10 millisecond latency with the cloud. Not in the same universe. But there are some things that the cloud does, like auto scaling, which promotes agility like nothing else in the world. This VPC peering concept, wow! It takes all the network complexity out of it. So you still need to understand the networking, but half the work is done for you. Now, if all your users are on the cloud, boy, that makes your network cheap. This is why the organizations are viewing this. What does it normally look like? The systems that I work on have a data center. Data center has 20,000 remote locations. You've got 20,000 private lines, which means you're paying for 20,000 lines. And you've got 20,000 routers, and each router's got at least 2 subnets on it, bare minimum. You could be dealing with 40, 50, 100,000 routes, 20,000 remote access connections, which could cost millions of dollars per month, or the tens of millions of dollars per month. And realistically speaking, things are going to work perfectly. So there are times where an organization needs to connect to a lot of people, and when an organization needs to collect to a lot of people, that's when, realistically speaking, you're in a really great shape using the cloud. So if you have to basically connect to a lot of people, you can create what's called a shared services PVC. And what does that actually look like? Instead of building connections to everybody in all your remote locations, or if you're a service provider and you want lots of people to connect to your service, you can use a shared service VPC. And what you would do is you'd set up all these private link connections between your remote access sites, and then they can all access the services they need in your service provider VPC. This is one of the most simple, one of the most elegant, and easy workarounds to shared services and networking I've seen in 25 years as an architect. I love this shared services VPC. It is simple, it is elegant, and it is wonderful. So, understand that. Now, if you're not using private link, the other way you can do these kind of things is with VPC peering. So when you're dealing with VPC peering, things can get pretty complicated pretty fast. And we're going to talk about fully meshed and hub and spoke environments and how to do these things kind of cool. Before I do that, does anybody have any questions? Chris, did anybody ask any questions in the last 10 minutes? We're on a new topic and it's going to get ugly, so I'm going to take a couple-second break here because this new topic is going to be kind of complicated and I want everybody to be fully refreshed. So Chris, text me if you see anything. Only things that I can actually see. I see something from Pistol Grip Vlogs and something from Joe White. Would you consider someone hireable if their networking is decent but their cloud design skills are intermediate with certification and some data center experience? Well, Pistol Grips, here's what I would say. If your networking skills are decent and your cloud design skills are excellent and your soft skills, emotional intelligence, communication skills, presentation skills are excellent, then I would consider hiring you. But what I would realistically say, I would never be able to hire anyone as a cloud architect if they don't focus on their communication skills, so I don't know your background. Cloud engineer, sure. Cloud architect, no. Cloud architect is a customer-facing executive role. It is at parity with management, and for these things, that's why it matters so much. So someone hireable if their networking is decent, it depends how decent. If the person knows how to configure the routers, meaning setting up an interface and turning on routing, no. If they understand how to design things, like as a network architect, absolutely yes. If someone has designed systems for real, done lift and shifts, done understand the network and the data center, absolutely, as long as they've got good knowledge of communication skills, soft skills, and the such. So I hope I answered your question there, and I'm happy to answer that for you personally. If you've got more desires, we can take some of these discussions offline. My team hates when I answer these questions, but I definitely do it. I will answer Joe White his question. Joe, as a rule, realistically speaking, my team is doing something with our costs in the next few weeks that are going up. If you reach out to me personally, I can give you a specialty coupon that will still work after July 2nd, so you can come out of the hospital and do what you want, or you could sign up ahead of time and we won't hold your time accordingly. And I see Vikesh, customers talking about, yeah, they do that, but okay, you've heard about such too. Yeah, so that Bastion host is a workaround to poor network design. Our desire is to use proper network design whenever possible. We understand why people do it, but the proper design is always better. And K1 Arzan, compare the cost, VPC pairing. Generally speaking, when we design systems as an architect, we design it and we hand it off to another team that does the costing. In order to do this, you must check every single time the pricing schedules that are with AWS, because they change constantly. They update things. So pricing cost, that has to be figured out each time. I don't specialize in pricing costs. I specialize in architecture, how to design systems, how to teach people how to design systems, how to teach people how to integrate systems, and how to build solutions that work anywhere, anytime. I don't do pricing. That's not really anything that I would possibly ever do or ever teach to my students. In order to do that, you can either have one of your junior people basically go to the page and do that, or you can basically go to the site and do it yourself. You got to look at things in an organization. An organization that's going to spend $300,000 a year for a cloud architect doesn't want you staring all day and configuring sheets. They can hire a person for $40,000 or $50,000 a year that does these things. So with your help, you basically tell them what you need and they can evaluate these things. So not a cloud architect skill, definitely important to be managing the process, but not something I would be able to guide you. What I would do is go to the web page just like any other person would do to determine the actual cost of things. I design the ultimate solution first, the way it should work based on optimal solutions, and then we remove things or modify things based on cost. That's why I say, as a cloud architect, you must prioritize. Start with ideal first and then work your way backwards if you have to. But always begin with the first one. It's based upon your desire. Okay, one more question that I'll answer. You're working full-time as a program manager. That's great. We've got lots of program managers in our program and that do our course. And the pace of the class is fine. Here's the thing. So K1, the designer, does configure the costs, but you're not going to be the person looking up the costs. You will definitely configure the cost, but you're going to have someone that's much cheaper and much more junior to you. You're going to give them the solution, and they're going to go back and do these things. So I'll go back to your question or garage. I have lots of people going through my program that work full-time, literally half of them. It's a 16-week program, but for people that work full-time, sometimes they take 20 or 24 weeks to go through. It's no big deal. If someone doesn't have the 10 hours a week and they only have 6 hours a week and 10 hours a week of studying outside of our courses, they just stay in the program longer. Nobody's rushing on you. Nobody's kicking anybody out. Everyone is making sure you get to your goal. Somebody Ranchit says, how do you prepare for the Certified Solution Architect Associate exam? Watch my free course on YouTube, download my free ebook, and then buy a practice exam. We recommend Review and Prep. Review and Prep, their CEO, Haman Sharma, is a wonderful, wonderful, wonderful person. He and I have had 30 or 40 discussions in the last few months. I deeply, deeply respect him, and I try and send everybody to Review and Prep. I get no financial benefit from doing this. I just send people so take our free course, read our free ebook, and then buy one of these program practice tests. I think they're under $50, and that's all you need to pass the Certified Solutions Architect Associate. And then for the professional, you can use this course, and again, buy a practice exam, read our book, and you're going to be good to go. And if you're one of my students, Ranchit, then all that stuff's included in our program for free anyway. You don't need to worry about it. Let's get back to VPC peering. So VPC peering is cool. What is VPC peering? VPC peering is the way that you take your systems and you connect them to another organization's systems. So where does this come from? BGP. When one organization connects to another organization, they run BGP between them to exchange routing information and filter things. How do organizations connect to other organizations? With VPC peering. You connect your virtual data center to somebody else's virtual data center, and you ride the AWS network. How cool is this? For network people like me, we're calling service providers, we're looking at lines of demarcation, we're looking at CPE devices and CE devices, and DC, well, we're not dealing with that anymore. Then we're dealing with the connections, we're buying connections, and we're doing all these complexity things. Then we're sticking routers and switches all over the place. It's all done here. There's nothing to do. 100% of it is all done by the cloud providers. This is like one of the coolest things ever. It makes life so simple. So that's why we love VPC peering. So VPC peering provides just what's called a non-transitive connection. AWS assumes that you have no understanding of networking and no understanding of BGP. They assume you don't know anything because they assume the people that are configuring these things, the cloud engineers, have an extreme depth of knowledge on how to configure things, but they don't understand how it works. So what they've done is they basically removed your ability to do proper routing because they don't assume you know how to do it. And in order to make VPC peering work successfully, you're going to have to then do new services to try and make these things work. And we'll talk about how to do this in a minute. But VPC peering is a way that you connect your things. VPC is not transitive, and communication uses the private IP space. And great news with VPC peering is if you're going between regions, guess what? Your traffic is even encrypted. So VPC peering is really cool. One of the benefits of the cloud. I'm in love with VPC peering. I think it is terrific. How does it work? You take your VPC and another VPC, you set up a VPC peering session, and you can all talk to each other. Brilliant, elegant, perfect solution. So much simpler than the way people like me have done it for the last 25 years. Now, VPC peering is not transitive. What does that mean? If I get information from VPC A and it goes to VPC B, VPC A's information is not passed on to VPC C. What does that mean? It means VPC A will not be able to talk to VPC C through VPC B. And if it's important that you're building a network where everybody can talk to each other, you're gonna have to do a lot of work to make this happen. So architecturally, we're going to discuss these things. So since VPC peering is not transitive, just like IBGP peering is not transitive, this means that if everybody needs to talk to everybody, you're going to have to do what's called fully mesh, which means you're going to need a connection from everybody to everybody versus hub and spoke. We will talk and show you why fully mesh is a disaster. Best performance, but it's a disaster from a scalability performance. Look at it this way. If you have 2 devices, fully meshed is 2 connections. If you have 3 devices, fully meshed is 3 connections. But it grows exponentially. What fully meshed means is you have this formula of n times n minus 1 divided by 2, which means if you've got 10 VPC peering sessions that you need to do, it'll be 10 times 10 minus 1, which is 9, which means 90 divided by 2. For just 10 connections, you've literally used up 45 VPC peering connections. Remember, AWS has a limitation of 125. That means realistically speaking, what that actually means is that you'll run out of VPC peering connections very, very, very quickly. Chris, if you can address Joe White's concern while I'm going over this. So, or with regards to ours. So VPC peering is not transitive, which means fully meshed, which means by being able to fully mesh your VPC peers, what you're actually talking about is a lot of connections. So I'm going to show you what I mean by non-transitive, and then I'm going to show you what I mean by fully meshed. In this environment, we've got all these VPCs. VPC A is in the center. If VPC A needs to speak to VPC B, and VPC A needs to speak to VPC C, and VPC A needs to speak to VPC D, and VPC A needs to speak to VPC E, and then F and then G, and only A needs to talk to these people, this is a wonderful, completely elegant, and perfect environment. Guess what? It's highly secure too. VPC B can only talk to VPC A. VPC B cannot talk to VPC C. VPC B cannot talk to VPC J. Only A will have the ability to talk to each other. This is great if this works. But what if VPC B needs to speak to C, and D needs to speak to C, and E needs to speak to C? Well, then you've got to do something that's very, very, very different. In these particular environments, what you need to do is fully mesh them. And what does fully mesh look like? It looks like everybody's got a connection to everybody. That's how you do it. So remember, n times n minus 1 divided by 2. Because n times n minus 1 divided by 2 gets bold and fast, you can just imagine. With 20 VPCs that need to talk to each other, you've got 190 connections. Remember, AWS only does 125. You can't even connect 20 sites with this kind of VPC peering if everybody needs to talk to everybody, so you got to do something different. What do? You use something called Cloud Hub or Transit Gateway based upon your situations. We're going to talk about Cloud Hub. What is it about Cloud Hub? Cloud Hub will enable you to break all the non-transitive rules of VPC pairing. So what's going to happen is Cloud Hub is going to enable you to connect to these things with multiple eBGP pairing sessions, and I'm going to show you what that looks like immediately. And then what's going to happen is the routing information will be passed from VPC 1 to 2 to 3 to 4. And because the routing information is passed, now we have transitive routing, and I'll show you what that means. So basically, AWS assumes you don't know how to do networking when they basically set up traditional VPC pairing. And then, if you know how to do networking, then you can opt for the service AWS Cloud Hub, and then you got to start configuring BGP. So you got to know some networking. So if you don't know networking, they keep you from making huge mistakes. If you do know networking, they give you options. And the option to use to fix all these limitations we're talking about is actually called Cloud Hub. Cloud Hub is a fantastic, fantastic, fantastic way to deal with this. What does Cloud Hub do? Is it enables you to create an environment where you can connect your VPCs in a hub and spoke environment. But let's say we've got a Sydney location, we've got a London location, we've got a New York location. They can all use VPNs, for example, or to connect to the VPC, and they can all talk to each other through the VPC. This is transitive routing, complete transitive routing. And this completely works because we're dealing with VPC connections and VPC peering. Next time we take a break, I'll talk to you guys that are new to IT, and we'll talk about answer your questions that are there, including Joe White. So bear with me for about 15 minutes. We like to go 20 minutes of discussions and 10 minutes of questions. So Cloud Hub enables you to do all of these kind of things. So Cloud Hub is a way to break the rules, to break the rules of non-transitive connections and get to your ultimate goals. So that's the way we do things. I will answer, Suleiman, I'll answer your questions in more depth on the break, but absolutely the answer is yes. That is the way Cloud Hub works. Cloud Hub enables you to bypass the VPC peering non-transitive rules. So now that we've talked about that, all VPC pairing, Thejo, is non-transitive. Non-transitive means it doesn't pass routing information from one to the other. The reason you're doing full mesh is to help you work very hard to bypass the non-transitive things. So that's why we're doing fully mesh, because that way there needs no So Thejo, it's a good question. If you're fully meshed like this, everybody's only one connection away from each other. So the problem is non-transitive is, let's say VPC, in a non-transitive environment, if you've got VPC-C connecting to VPC-A, VPC-A won't pass the connections to VPC-B. That's why it's non-transitive. That's why VPC-A can't talk to VPC-B through A. But fully meshed means you basically make a peering connection between everybody, and that way you're working around those connections. So VPC peering is designed, VPC pairing is always non-transitive unless you use Cloud Hub, which breaks the rules of doing it. What I probably need to do, Thejo, is describe some more networking. So I'll talk about, I have a networking video that I'm going to release in a couple of days that's going to be an intro to networking. And then after that, it looks like people want. So I'll come up with like an 8 or a 10-hour networking course, which I'll do via YouTube Live coming soon. It'll be nothing like the training that my students get in our organization, because, you know, they pay to be part of our training and mentorship program, and they all do well. But I try and produce the best quality free content that we can for the internet, and I'll do some free networking things that'll explain BGP in more depth and talk about transitive and non-transitive connections, because all of this stuff, literally all of this stuff, 100% of it all comes from BGP, which all comes from networking, which is why I say in order to be an architect, you need to know the network in the cloud, because everything you're doing is networking and data center things in the cloud, nothing else. So let's talk about how do you protect traffic from entering things. So we're going to talk about security. When we talk about security, we're going to talk about protecting the perimeter of your network, dealing with intruders that could pass your firewalls. We'll talk about DDoS protection. We're going to talk about it all. And all of these things, all of them, 100% of them are going to be required to actually design an architecture. A network ACL and a security group are a small percentage of the security architecture. Many, 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 many other things are required from both the networking side as well as the non-networking side, and we'll talk about all of them. We've got a lot of time where we're going to talk about security, but you keep traffic out of your network with a firewall. You block traffic that gets into your systems with an IDS. You thwart the attack. You use some kind of a DDoS protection, and then you have to protect your subnets. How do you keep unwanted traffic out of your subnets after your firewalls, your IDS systems, your DDoS protection? You put normally an access control list on a router. But since in AWS you don't have any control of your routers, you use a virtual router. The virtual router you're going to put an access list on. What does AWS call an access list? A network ACL. A network ACL keeps the traffic out of a subnet. A security group keeps the traffic out of a host. I'm going to say this again. It's a test question and people always confuse it. A network ACL keeps unwanted traffic out of a subnet. A security group keeps unwanted traffic out of a host. So your network ACL is going to be what you're going to be using to keep traffic out of your subnets. Now, anytime you're dealing with an access list, they all have a default policy, which means deny everything. So the only thing you need to do is your permits, unless you need to be explicit about something else. Now, network access lists are stateless. So when we talk about state, what it means is something that's tracking the connection. So when you go out a firewall, the firewall is saying Mike's traffic went to Cisco.com. The traffic from Cisco.com going back to Mike is allowed because I know it's Mike's traffic because I'm watching and I'm stateful. Network access lists are not stateful. Nobody's paying attention to the connection. Since nobody knows what traffic's going in and out because nobody's monitoring because it's stateless, you must configure your network access list in both ways. Otherwise, the router or the virtual router will have no way to track your information. None whatsoever. All of this information is tracked in a firewall, but it's not tracked here. So this means it's stateless, meaning no state, no information, no tracking. You have to apply them in both directions. Now, when you're dealing with access lists, they get tricky, not because they're complicated, but because the order matters. If you get your order wrong, all kinds of chaos will occur. And I'm going to show you what I mean by this. If I take you to this screen, this is a poorly designed access list. Order process is first. So if I create a rule 100 that says deny everything, and then I create a rule 110, for example, and then rule 110, it basically says allow port 80 or web traffic in, and I do the same thing for outbound, deny everything, but permit port 80, what happened? Rule 100 is processed first. Rule 100 says deny everything. Packet comes in, it's already denied. It can't be processed by the Rule 110 that says permit. It's already blocked. Don't do this. The order matters. You have to be very specific about what you want to permit and what you want to deny. It would be totally appropriate to have a rule that would deny a single host and then another rule that would permit the entire subnet. That could work. But you have to be very specific and the order matters. You must do it in the proper procedure. So make sure you explicitly, the rules matter, and they matter because you don't want like a rule that says deny everything or permit everything before it. So let's say we had a rule that's 100 that says permit everything, and then after that we had a rule that said deny. Wouldn't matter. All the traffic's already been permitted and put through. So that's why these things matter. Order matters. So when you're making an access list, order matters. Now I'm going to give you some more guidance from years and years and years and decades of experience configuring access lists on routers and firewall policies. Give yourself a lot of room. You might think you can create a rule 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You can't. Because what happens is you create rule 1 and 2 and then you get a security violation and you need another one. And how are you going to fit it there if you don't leave any space? So basically leave a minimum of 10, maybe 20 in between these kind of things. So that's what you're actually doing. You need to leave space. So rule 100, something. Rule 110, something. Rule 120, something. Why? Because when you need to add a new rule, what you're basically doing is you're going to stick it in order, and you need those spaces to do it. So that is how you basically do this. So now what would the proper technique look like? The proper technique would look like this. Inbound, allow port 80 traffic for port 80 web traffic. Outbound, allow port 80. Everything else is denied by default. So that's all you need to do. So now let's look at this in the concept of what it looks like. And I want to show you this again. Basically speaking, at the edge of your network, you're going to have a firewall, which is not listed here. Behind the firewall, you're going to have an intrusion detection system, intrusion prevention system. All my students know this. This is part of every high security environment. Then you're going to have some DDoS protection. Then you're going to protect your subnets with a network ACL, and then you're going to protect your host with a security group. And of course, none of this is really good enough. You're going to put some endpoint protection. You're going to disable unnecessary services on your systems. You're going to provide some anti-malware on your services, and this is just part of it. But the network ACL is maybe one part of 50 pieces that go into your security posture, and it protects the traffic for your subnets. That's what a network ACL does. It protects the traffic for your subnets. So, and then we'll get to your questions at the next break. Now let's talk about security groups. Security groups keep unwanted traffic out of a host. A security group is effectively a stateful firewall for the host to protect your host. Remember what I told you about stateful firewalls. They track everything that goes on. Got a firewall connected to the internet right behind me right now. My traffic goes through the firewall to the internet, and when the traffic comes back, the firewall says, is this return traffic destined from somebody that initiated internally? Yes, the answer is yes. Welcome and allow through. This is a wonderful, wonderful, wonderful thing. Thank you. So security groups are stateful firewalls. Because they're stateful, because they track the connection, they only need to be deployed in one direction. Stateful does not mean it needs to be deployed in one direction. Say that on an interview, the interview is over. Stateful means tracking the state of the connection. And because it's tracking the state of the connection, and it knows what's allowed inbound, it knows to allow the return outbound traffic out. This is what a security group does. Yes, I know I'm putting a lot of interview training in this. I'm trying to talk about some architecture training, and all this is completely outside of the Certified Solution Architect Professional. I want to give you guys the best possible chances to build the best possible careers, so I'm giving you the information you need to know. Now, security groups only support allow rules, which means all non-allowed traffic will be denied, which is fantastic. So they're stateful, only inbound. Now let's go back to what these things kind of look like. And when we start looking for some of these kind of things, let's actually talk about it. So I'll show you what it looks like. Going back to the thing, we'd have a firewall, we'd have an IDS IPS system, we'd have the DDoS protection, then we'd have a network ACL that protects the subnet, and I painted them in blue, or at least my graphic artist did. We're going to use a security group, and so Hassan, stateless means nothing is tracking the connection. Stateful means something is tracking the connection. Stateless means nothing's tracking. If nothing tracks it, you don't know what to allow back in. Stateful means something's tracking the connection. So before we start talking about improving performance and playing with some things that can actually make things better, and before we get into placement groups and DNS and all this kind of cool fun stuff, let's talk about one more thing that you probably need to know about, especially when you're dealing with security. When you have data coming in and you've got data coming out, and if you're dealing, you need to see what your data is looking like. What do I mean what your data looks like? If you might want to know your data comes from point A to point B, you might want to know that your data is being blocked by a security group and therefore it's not getting in. You might want to know that a network ACL is in the way. You might need to know that your links are fully utilized. You might want to determine what kind of traffic is routing over your network. People like me have been using Cisco NetFlow like this for 20 plus years. Cisco NetFlow gave us the ability to actually see what our traffic looked like. Because AWS needed that functionality, they created something called the VPC flow log, which guess what? Just like Cisco NetFlow. It's just all this stuff is all networking stuff that's just being copied over. So security groups, Hassan, are stateful and network ACLs are stateless. Well, maybe we'll do that again if you guys need. So it's very similar to NetFlow. So flow data that you connect is basically regards to your application flow, and your application flow goes from point A to point B, and you can capture this with flow logs. So if you've got a connection problem, useful. If you're running into contention or network congestion, you can notice it. You want to know which traffic is reaching your interfaces and your application flow. We can take care of these things. So that's what VPC flow logs are. VPC flow logs enable you to determine your source of your traffic from point A to point B, and that's why people use them. Basically, the kind of information you're going to be able to receive, and the way you set it up, you'll be able to capture the traffic, whether it was accepted or rejected, and then you'll be able to look at the data, the protocol, the ports, the port number, the source and destination. This is a graphic, obviously, we took from Amazon, and that's why we sourced it there. This is what it looks like. You'll see your account identifier, your source address, your destination address, your port protocol, and your port numbers, and basically whether a packet is accepted and rejected. This is excellent, excellent, excellent information to help you diagnose connection problems and make very good decisions in your planning of your things. That looks like a natural place to take a break. Saw a couple of questions. I'm going to address the questions, and then we're going to go into the next section. The first question came from Joe White. So Joe, to answer this question quite simply, we have students from a wide variety of backgrounds and a wide variety of careers and a wide variety of jobs. I have people with zero experience, and I work with them and help them find a job, no big deal. I have people that are new to tech, no big deal. I have people from customer service, I have people from medicine, I have people from healthcare, no big deal. We know how to get them trained, and we know how to help them find cloud architect jobs. That's not a problem. What Alonzo was saying is that you can do it on any pace that works for you. Alonzo is one of my students. He's been with me for a couple of weeks, and he's going to be ready to be hired in about 2 more weeks. Normally we say 16 weeks, but Alonzo's been spending about 10 hours a day doing things, and Alonzo's been editing my blogs and talking to me every day about that. So Alonzo, in 3 weeks, has gotten about 20 weeks worth of experience. He's one of the resumes that I'm going to be submitting to AWS because I spoke to their hiring manager. I'm very impressed with Alonzo by the work he's done. So Alonzo puts in 10 hours a day. Because Alonzo puts in 10 hours a day, he doesn't need to be in my program that long. I have people that work a full-time job and have 2 children, and they can only study 6 hours a week. They don't get through in 16 weeks. They get through in 6 months, 8 months, 9 months. It's okay. We work with people based on how much time, effort, and capabilities they have. All we care is they get to their goals, and all we care is they get hired in the end, and that's what we do. Everybody is a unique person. We can't force everybody into the same. We can't force a round peg into a square hole. We need to optimize and do what we need for everybody, and that's what we do. So I hope I've answered your question there, Joe White. If you've got more questions, you can put them there. The next question that I saw along the way is from YHEM. In my experience, how common is it to use ACLs in a large environment with different security layers? It depends on the requirements of security. I work in security environments where we use 802.1x authentication to determine whether people are even allowed on the system by their MAC address. Then we stick them in a private VLAN. Then we do route filtering on the routers. Then we do access list firewalls, host endpoint protection, in addition to route filtering, in addition to network ACLs, in addition to security groups. And after the security group, we put a second host-based firewall and malware protection. So it depends on the needs of the environment. Half of the environments I use work access list, the rest do not. QoS is probably more important than ACLs in a lot of different places because you need to make sure that your good data can come in. And if you don't use QoS in your links, a worm or a virus can easily fill up your links. So in high security environments, we do all of these things, YHEM. All of them. In low security environments, people don't do them. But in the cloud, your security is much reduced compared to your data center because you've got less features and functionality and systems you can use. In the cloud, you can do this. Now, Hassan, good question. Where does WAF, Shield, etc. fit in my architectural design? If I were to use WAF, and I wouldn't use WAF for anybody that mattered, but if I were to use WAF, WAF would be, I would secure my systems with the perimeter of my systems, I would secure with a firewall. Behind the firewall, in real life, we're going to use an IDS IPS system. Behind that, we're going to have some DDoS things. Then we're going to have a network ACL, then a security group. I don't use WAF that often. And the reason I don't use WAF that often, WAF is not an industrial grade firewall. It does not provide industrial grade security. If you need true industrial grade security, like the kind of companies I work for, you're going to have to go to the marketplace and you're going to have to get something from Cisco, Palo Alto, or Fortinet or Checkpoint, something that's got a lot of rich feature set. So none of the functionality that we're actually getting, even though they say it does, from WAF is going to be sophisticated enough for anybody to use it. People are going to be using, if it matters, large global enterprises, the kind of people that would consult with me, are not going to be using WAF. They're going to be using IDS and IPS systems, and they're going to be using firewalls from places like Juniper, Palo Alto, somebody doing it. That's where they're going to do it. Now, if it's a small business, if it's a company like mine with 10 employees, and we're hosted on the cloud, we're going to use WAF as the firewall, which blocks the edge of the network. In reality, for most organizations, we're not even going to think about using WAF. It's just not good enough. We're going to get something from the marketplace. I hope I've answered your question there, Amit Patel and Hassan. The next question you had, Hassan, is stateful means watching the connection. So let's take us out of the firewall and access list rule, because this stateful thing is really important. It pops up on interviews, and I will tell you, when people can't get this right on an interview, they can't get hired. So, because it basically goes to fundamental understanding of concepts. Stateful means watch the connection. Let's say you invited someone that was a guest to your house. Let's say you opened the door for the guest and your guest came in. Let's say Chris came to my house yesterday or 2 days ago. I opened the door for Chris. Now let's say Chris wants to walk back to his car. He opens the door and walks back to his car. He then walks right back into my house. He's allowed. Why? Because Chris is my guest. I invited Chris in and I know Chris is here. Now, Chris is awesome. Let's say by comparison, I didn't know Chris was coming and he just walked into my house. That'd scare me because I would have no state. I would have no knowledge. So stateful means I know what happened. So I know Chris entered my house. I know Chris can leave my house and he can come back in my house because I know him. He's already come in. That's what stateful means. Stateless would be if some stranger off the street were to try and come into my house and I didn't know who they were. I would just keep the door locked. Or if a stranger came into my house and I didn't see them come into my house and they walked out of my house and they came into my house again and this time I saw them, it might be problematic for that stranger. I might act in a way to defend myself. Why? Because I don't know. So a stateful firewall is like me watching the door. Goes out the wall, out the firewall is tracking it. Says, okay, I know it's Mike Gibbs traffic is destined for the internet. Mike Gibbs traffic is it's coming back to Mike Gibbs, it's allowed in. Just like the guest in your house. I hope I've answered that question for you, Hassan Ahmed. And if I have, I hope so. If not, let me know. Before we get back in, we've got about 30 minutes and we're going to enjoy the last 30 minutes of lecture. Does anybody have any questions for me? Now I've gotten about 20 text messages so far for people asking either the program or the program price or the syllabus for the program. So I am going to leave a link to the program again, along with a coupon that we're actually offering right now temporarily in the description and in this chat window. And then I'm going to get back to teaching. So, and if people had questions for me, this is the last week I'm being allowed to do this. Regarding your career or how to plan it or how to get to your goals, here's my mobile phone number. Last week I can do this because it's becoming challenging, but I want to make sure we answer your questions. You guys have all invested a lot of time with me this week watching this presentation, and I want to make sure we can do everything we get. Rick Yetsy Transit Gateway is just like another form of Cloud Hub, but it's basically used for VPC pairing. Not really part of this exam, not really something to focus on. It's like a form of Cloud Hub used for VPC pairing and connections. More with direct connections, I believe. So now let's talk about network performance optimizations. And one more question, can you also please tell the well-known alternative to third-party security solution, WAF and Shield? So most people use Cloudflare for Shield. All the content delivery networks have their own DDoS protection. And for the most part, every business in the world buys a firewall from either Cisco, Checkpoint, Palo Alto, or Fortinet. So absolutely. And Emmanuel, our whole program is designed to help you get hired. Our students get hired all the time. We don't create a program to do certification and dump people when they're done and say pass an exam. We have a process to get people hired. We have 60 recruiters we hire. We do everything we can to help our students get hired, and our students get hired constantly. And we have no problem getting our students jobs, assuming they have the right attitude, the right energy and enthusiasm, and they do the work that we tell them to do. It's very easy to get hired. There's hundreds of thousands of cloud architect jobs. The only problem is the last 1,000 people that I interviewed, none of them had the capability to do it because they only knew how to be a cloud engineer. They didn't have the soft skills, the emotional intelligence, the verbal skills, the design skills, the understanding of the network and the data center. So Emmanuel, that's all we do is we help people get cloud jobs. Our whole program is helping you getting hired. It's not based on certification, it's helping you get hired. We do certifications because it helps you get interviewed. The rest of the 90% is what we focus on as a company. I do the certifications for free. And the reason I do all these certification training things for free is as follows. I saw the certification course providers that are actually out there, and I saw the training that they made, and I was so unimpressed and disgusted by what I saw. I couldn't believe they were charging people to buy stuff like that. So I made a book and gave it away completely for free, and I make training courses for certification, and I give it away for free because I want you guys to have options in your career. So certification is 10% of what we do. The other 90% is related to getting you hired. Joe, these topics. So Joe, if you're in our course, we cover every one of these things. If you're not in our course and you don't need to be, go to Cisco and learn these things, go to Palo Alto and learn these things, go to Fortinet and learn these things, go to VMware and learn these things, read the Kubernetes documentation, read the Docker documentation, read all the Red Hat documentation, read the F5 information for DNS and load balancers. You can do that on your own. We've consolidated 25 years experience into doing that to basically help you get your job as fast as possible. You can learn all these things on your own. It will take you 3 to 5 times longer. The average cloud architect earns $600 a day, and time is money. And if we can get you a job 6 months sooner than you would on your own, which is basically nothing, that equates to about $75,000 of benefit for you. If I get you a job 1 day sooner, it paid for my entire program. So now it's time for me to go back to actually talking. I don't like to talk about our programs too much. I like to provide the information for you. And then if you'd like to work with us, we've got a lot of people. We love to work with our students, and we love helping people get hired. So you know how to reach me if you've got questions. Let's talk about now optimizing performance of your networking inside of the cloud, which is a world I like. And because I've been reminded via Slack, if you guys don't mind leaving a like, a comment, or forwarding this video to others, please do so. It helps the algorithms know the work that we actually do when we train the cloud architect community. So let's talk about the things that we're going to talk about inside of networking and performance. We're going to talk about placement groups. We're going to talk about single root I/O virtualization. We're going to talk about Elastic Fabric Adapter. And then we're going to talk about load balancers on Route 53. I don't know how much of this we're going to get through today. Whatever we don't get through today, we're going to get through tomorrow. So let's start talking about placement groups. So as a rule, when you need low latency, what you can actually do is you can put your instances very close to each other. Close to each other. Why do I often tell you that the cloud is not anywhere near as performance oriented as the data center? When you're connecting to the cloud, you've got a fiber optic connection to the cloud. The cloud could be hundreds or thousands of miles away. It takes time for the speed of light to get from point A to point B. That is in the form of milliseconds. Milliseconds. Some things, sometimes a nanosecond is a competitive advantage. I've worked with algorithmic trading applications for the big banks, and we literally take the biggest servers you can possibly buy, something you couldn't possibly even get on the cloud, put 10 of them in the same rack, all connected to the same switch. Why are we doing this? By getting everything super close together, we can get that latency in the nanoseconds versus milliseconds. And if you're placing trades for 1 million shares of something, and you can get it 30 cents cheaper, that is, basically $300,000. And organizations deal with this stuff 20, 30, 40, 50, 150 times a day. So realistically speaking, that's where these kind of things work. And that's why organizations do things like this. They are looking for strategic and competitive advantages. And that's kind of why organizations do these kind of things. So when you're dealing with in the cloud, you've got a lot more latency, and you've got a lot more latency because you're in this environment. So what do? You have the equivalent of a placement group in the cloud. So we're going to talk about placement groups, and they're basically a way that you can spread or condense your systems to give you higher performance. So here's the way this kind of thing works. Placement groups are logical groupings of your computers in a single area availability zone. By doing this, you get your computers closer together, you can reduce your latency. So when you place these things close to each other, you get lower latency, higher packets per second, and higher network throughput. But there's a cost. 1 is none, 2 is 1, and 3 is greater than 2. It goes back to availability. If you put all your systems close together and you have a problem in that area, everything breaks. Remember I told you in the beginning, there's no such thing as a perfect architecture, and you have to prioritize and make the right decisions. This is one of these things where your applications will determine your architecture. If, for example, you need incredible performance, I mean really incredible performance, and you put your things in what's called a cluster placement group. A cluster placement group is the lowest latency option you have on the cloud. Basically what a cluster placement group is, all your stuff is in the same rack, it's often in the same server, and it has extremely low latency, and it's the best network performance you can get on the cloud. Why? Let's say you've got a dedicated server, it's in your cluster placement group, and you're never even leaving the server because all your data is stuck inside the same server. That is fast. It's about as fast as you actually get. So that's why organizations do this. They place their stuff in a single rack. Now, architecturally, I want you to see what this looks like. All your instances are on the same rack, and in some cases, all on the same server. Can anybody think of a problem? Well, if the power to the rack goes out, you're done. If the switch in the rack goes out, you're done. If the server that all your systems are on goes out, you're done. High performance, horrible, worst in the world availability. When I design these systems like this for banks, we use these algorithmic trading environments, and they're in their data center because they need better performance, because the performance in the cloud is not good enough, although now we're getting closer with edge computing, but not good enough. And we do a cluster placement group equivalent. We have another one, identical copy, and we're doing redundant routing across redundant network connections, across redundant switches, across redundant power, all kinds of things. If you're going to use an environment like this, make sure you've got backup. It is not stable. Everything in one thing, multiple single points of failure, but absolutely fantastic performance. Wonderful performance. And Hassan, we actually covered that in depth yesterday. You can watch yesterday's video and we'll tell you about all the tenancy and the options. So given, go back over to here. Given that that's not absolutely the best solution for certain times, you might need it if you need ultimate performance, but you're not going to need it if you don't have optimal performance. But you might not be okay with the limitations of scalability. So what could you do instead? You could do what's called a partition placement group. And a partition placement group will basically give you enhanced performance because it's going to spread your group across the racks in the data center. So if you've got a single power failure, you're protected. If you've got a switch failure, you're protected. If you've got a server failure, you're protected. You're still getting high performance. And why are you still getting good performance? The reason you're getting high performance is as follows. You're still in the same data center, so the latency between your devices is minimal. So you can be sub-millisecond latency all in the same data center, or at least a millisecond or two. So this is great. Partition placement group enables you to spread your things out, remove single points of failure, but realistically speaking, enables you to help to do things high performance. And what it's going to look like is as follows. You've got your racks, and your systems are spread across the racks in the data center. The data center availability zone is synonymous. So by doing this, lots of high performance in a single availability zone. You still have a single point of failure because you've got the single availability zone, but great performance and some redundancy, which is far better than the cluster placement group. Cluster placement group gives you much better performance. Partition placement group gives you much more redundancy, and it's a good thing. And after that, you've got one other option. What if you still want good performance, but you can't deal with the risk of basically having everything in a single availability zone? Then what you can do is you can create a spread placement group, and instances are spread across hardware, racks, servers, power distributions. They can be spread across multiple ADZs to have high availability. So higher latency, much higher latency than the other options, which means lower performance, a lot of high availability, compared with the cost of this is performance. In every architecture decision you're ever going to make in your entire life, you will always, always, always have to trade something, availability, performance, something like this. Here's what your spread placement looks like. Lots of your stuff in a single availability zone, some other stuff in another availability zone. Moderate performance, lots of protection. The concept of placement groups are not just with AWS. Concept with Google, you built in OpenStack, Ansible Cloud, and Nutanix Cloud. This stuff exists everywhere. Placement groups are one of the things you do in the cloud computing environment to get around the poor performance of the cloud to try and improve things. See, the cloud does not perform as well as the network in the data center because it's virtualized, and virtualization can cost upwards of 30% performance. So because we're on the cloud, we need to know the network in the data center so well so we can know what the performance requirements are and the systems that we're migrating to the cloud, and then how we can make them feel on the cloud relatively good enough. So that's why you can't just get certified. That's why you need to understand the network in the data center. Otherwise, you can't design things. You can't cook a food that you don't know what the ingredients are, and you can't design things if you don't know what they are. So it is not hard to get a cloud architect job. It's very, very easy. It's very hard if you're a cloud engineer applying to be a cloud architect because it's a different skill. And a cloud architect couldn't apply to be a cloud engineer because it's a different skill. Train for the job you want, don't have any problems, just make sure you know that. Now let's talk about some other network performance options. So when you're dealing with the virtualized environment, you're dealing with virtualized cards. You're dealing with virtualized things, virtualized GPUs. Guess what? They don't perform that well. I'm going to say it again. Virtualized devices do not perform anywhere close to physical devices. Why? Virtualization is done in software. Software has to hit the CPU, and it's slow. Other things outside of it are done in hardware. Hardware is really fast. When people do blockchain calculations, for example, the biggest, baddest CPU of a $100,000 server might be able to do a few thousand hashes per second for, say, Bitcoin SHA-256 encryption or caching algorithms. But you might be able to buy a machine with an ASIC that's hardware that does 20 terahashes, which is like 1,000,001 times better. And it's a lot cheaper. Why? Because hardware does things faster than software. So when you need high performance networking, what do? You use physical network hardware. So what do you mean? I mean by this. VMware would call it single root IO virtualization. What it means is you take your virtual machine and you pass a physical network card in your virtual machine. That gives you high performance. That means your virtual machine now has the performance of a physical card. Again, one of these cloud workarounds, physical card in your virtual machine. Now let's look at GPU optimized instances, instances that are used for machine learning or AI or any of these other scientific computing calculations or rendering. You're taking a physical graphics card, like a Quadro 8000 or something like that, and you're pushing it into the virtual machine. It's called PCI pass-through. So when you need high performance on AWS, you're going to use some form of single root IO virtualization, which is basically pushing the physical network card directly from the server into your virtual machine. It's going to cost you more, but you're going to have better power. AWS has also designed something very different, and they've decided something called the Virtual Fabric Adapter, and that's a specialty driver for a specialty high-performance card. They can theoretically go up to 400 gigabit per second. It doesn't do it now. They designed it to do that, but it can get you relatively decent network performance as well. So now we're going to start getting into Route 53. We have 15 minutes. I don't know if we have enough time to actually cover all of the DNS things that I would actually like to cover. So here's a question you guys tell me. I can do DNS in Route 53. It's going to take me 30 to 40 minutes. If you guys want me to cover it today, I will cover it. Otherwise, we were going to move it to tomorrow. Guys, let me know in the comments section. If you want me to cover DNS and Route 53 today, I can do it. Otherwise, I'll open it up to questions and answers and career development, and we'll come back and do it tomorrow. You guys tell me, and I'll do anything I can to make you have a great experience. It's hard to listen for a long time, so I don't know where you guys are at. Tell me. Cam. I see 2 votes for tomorrow. I'm waiting to see. There's 50 some people on the call, so I'm waiting to see what the rest of the people say. We need to know a majority. If you want me to cover it today, great. Cover it tomorrow. I can do it tomorrow. You guys got to let me know. Okay, there's still about 40 some more people on the call. I need you guys to let me know. Okay, I'm going through these things and it's looking like a lot of people want me to move on to DNS tomorrow. I'm happy to do that. Because we have 15 minutes left that I fully allotted, I'm going to open it up to questions. If you've got any career questions, you can ask them and I'll help you. If you've got any tech questions from the last 2 days, I'll open up to tech questions. And how would you like to, do you have any questions for me then? Since we've decided to move on to DNS tomorrow. There's about a 30-second delay from between the time I actually speak to the time you guys see it. So that's why if I sit here like I'm looking like I'm waiting, that's the reason why. So it's quite possible that everybody's getting really tired. I covered a lot of networking today. And when I cover a lot of networking, if you're not used to networking, it can be exhausting for people. So here is the last link that I'll post for our training program today. And I'm going to post a coupon code for 20% off. If anybody has any questions or wants to reach out to me, they can call me. Last week I'm giving out my phone number because we've grown too big, too fast. And we've got such extreme success with our students that I'm putting my phone number one more time. If you've got any questions, you can text me after this call, or you can do whatever you need to. I've dedicated about an hour to be able to return questions after this call. So I will close this call today unless anybody has any more questions. My associate has come up with a form for the boot camp to basically let us know how you found us. It's very important for us to know, how you guys find us and what you guys like and don't like, because we really work hard to provide. Oops, I didn't mean to do that. We work hard to provide some really good free training program to the community. Joe White, if you have no experience, it's a great question. Sometimes it takes longer than 16 weeks. I'd say, I've got some people with no experience that have done it in 16 weeks. I had a Nigerian student, he's really amazing, that came with me with no background and he had a job inside of 3 weeks. But I think he worked 24 hours a day for the 3 weeks straight. And then when it came down to it, he followed my things. He scheduled a private specialty private interview session and poof, he was hired. That's the answer. So Joe, it's based upon the information in your background and how fast you learn. 16 weeks for people that have a little background, 6 to 8 months for people that have zero background. But if you can get a job that's basically a brand new career in less than 6 months, we consider it to be a good success. Thank you, Derek. Oh, apparently my associate told me that when I tried to share the link to the information gathering thing, that what I actually did was provided a coupon code. So I'm going to pop that in here as well. Almost everybody asked me to cover DNS tomorrow, so we're going to cover it tomorrow. I want to make sure you guys are all having a great experience, and we'll do anything we can to really boost everything we can do for you guys. So it's been a real pleasure. Any last minute questions for me? Okay, if you have enjoyed the day, if you can comment Cloud Architect in the box, I will take that as a way to end the day and know that everybody's been here and enjoying themselves. We will resume again tomorrow at 12 p.m. Eastern, 5 p.m. England time. Avanish Kumar, if you enroll in the course, we are getting paying placement. We have 60 recruiters that we use to try and help you guys find your jobs. It's very important to us that we do. We also encourage you to get your recruiters. We provide you enough support that our students have a very easy time getting hired, Avanish Kumar. And if you've got any questions, you know how to reach me. I've dropped in my phone number. If you filled in the form yesterday, no need to fill it in again. Thank you, Belwinder. But if you're having fun, please type the word Cloud Architect. YHAM placement groups are not the most common things to do, but they are used by enough environments that you need to know. Derek, soon to be a cloud architect, that's the attitude, that's the right approach. Balwinder, you're welcome. Thank you all, everyone. It's been a real pleasure. We will speak to you tomorrow.